On October 3rd, 2025, something extraordinary happened in the darkness between Earth and Mars. As 3I Atlas streaked past the red planet at a distance of just 29 million kilometers, every piece of monitoring equipment we could aim at, this mysterious visitor began recording data that would fundamentally challenge our understanding of what interstellar objects are supposed to look like. What started as routine observations of humanity's third confirmed interstellar visitor has transformed into something far more unsettling. The numbers coming back from Mars don't make sense. The trajectory calculations are breaking our models, and the chemical signatures we're detecting through our most advanced telescopes are painting a picture of an object that shouldn't exist, according to everything we know about comet physics. Tonight, we're diving deep into the anomalies that are multiplying around 3I Atlas, because what we're discovering about this cosmic wanderer is forcing astronomers to question whether we truly understand anything about the space between the stars. But first, let me give you the context that makes this discovery so extraordinary. When 3I Atlas was first spotted by the Asteroid Terrestrial Impact Last Alert System in Chile back in July, astronomers thought they had found another routine interstellar visitor. Sure, it was moving fast at over 58 kilometers per second relative to our Sun, and yes, it was following a hyperbolic trajectory that clearly marked it as coming from beyond our solar system. But after the excitement of discovering Oumuamua in 2017 and Borisov in 2019, the scientific community had developed protocols for studying these cosmic nomads. What nobody expected was an object that would systematically break every assumption we've made about interstellar visitors. The more data we collect, the stranger 3I Atlas becomes. And today's Mars flyby has provided us with observational opportunities that are revealing just how deep this mystery goes. Here's what should terrify every astronomer working on this project. When teams tried to trace 3I Atlas back to its point of origin, using our most sophisticated stellar catalogues, they hit a wall that nobody saw coming. The backward integration models that should reveal which star system ejected this object into interstellar space came up completely empty. Not inconclusive, not uncertain. Empty. Dr. Perez Couto's team ran their calculations back 10 million years through galactic space, checking 3I Atlas against 3.6 million stars with complete motion data from the Gaia Space Observatory. They found 93 potential stellar encounters that might have gravitationally influenced this object's trajectory. Every single one failed to produce meaningful results. The closest candidate star would have imparted a velocity change of roughly 0.5 millimeter per second to 3I Atlas. That's not just insignificant, it's essentially nothing. To put this in perspective, imagine trying to trace a bullet back to its gun by examining every possible firing position within a 1,000-mile radius, only to discover that none of them could have produced the trajectory you're observing. That's the situation we're facing with 3I Atlas. This object has no traceable ancestry within our current observational limits, but the missing origin story is just the beginning of what makes this visitor so unsettling. When the James Webb Space Telescope turned its unprecedented infrared capabilities toward 3I Atlas in August, the spectroscopic data revealed chemistry that defies our understanding of how comets are supposed to behave. The gas cloud surrounding 3I Atlas, what astronomers call the coma, is dominated by carbon dioxide in proportions that should be impossible. Webb measured a carbon dioxide to water ratio of approximately 7.6 to 1. Most comets show the exact opposite pattern, with water ice being the dominant volatile component and carbon dioxide playing a minor supporting role. 3I Atlas has flipped this relationship completely upside down. Only one other comet in our extensive database has shown carbon dioxide levels anywhere close to this extreme, and that object was already considered a bizarre outlier. 3I Atlas is pushing into chemical territory that our models simply don't account for. When you combine this with the object's location at the time of observation, roughly 3.3 astronomical units from the Sun, the chemistry becomes even more puzzling. At that distance, solar heating should be insufficient to drive the kind of massive carbon dioxide outgassing we're observing. Yet 3I Atlas is producing a coma that extends hundreds of thousands of kilometers from its nucleus, creating one of the largest carbon dioxide clouds ever detected around any comet. The physics of this process challenges our fundamental understanding of how volatile materials sublimate in space. The Mars flyby data is adding entirely new layers to this mystery. Multiple spacecraft in orbit around Mars, including the European Space Agency's Mars Express and NASA's MAVEN orbiter, were positioned to observe 3I Atlas from angles impossible to achieve from Earth. The preliminary results from these observations are raising questions that nobody anticipated. The dust being ejected from 3I Atlas is behaving in ways that contradict every model we have for comet particle dynamics. When astronomers measure how light scatters off dust grains in a comet's coma, they can determine the size, shape, and composition of those particles. This technique, called polarimetry, has been used successfully on hundreds of solar system comets to understand their internal structure and formation history. 3I Atlas is producing polarization measurements that don't match anything in our databases. The degree of polarization and how it changes with viewing angle suggests dust grain properties that are unprecedented in solar system observations. The negative polarization branch, a specific signature that occurs at small phase angles, reaches depths of nearly 3% before inverting around 17 degrees. This combination of depth and narrowness has never been observed in any other comet. What makes this even more significant is that polarization signatures are incredibly difficult to fake through natural processes. The microstructure of dust grains, their porosity, their composition, and their aggregation properties all contribute to how they scatter light. For 3I Atlas to produce such unusual polarization, its dust must have formed or been processed under conditions that don't exist anywhere in our solar system. The trajectory data from the Mars encounters is revealing another anomaly that has mission planners scratching their heads. Despite 3I Atlas showing clear signs of active outgassing with a visible coma and dust production, orbital mechanics experts have detected no measurable non-gravitational acceleration in the object's path. This might sound technical, but it represents a fundamental violation of comet physics as we understand it. When a comet vents gas and dust into space, those escaping materials carry momentum. Newton's third law demands that this creates an equal and opposite reaction force on the comet's nucleus, slightly altering its trajectory in measurable ways. Every active comet we've ever studied shows these non-gravitational forces. 3I Atlas appears to be immune to them. The object is clearly venting massive amounts of material, yet its trajectory follows a purely gravitational path with no detectable deviations. The implications of this observation are staggering because it suggests either that our understanding of momentum conservation is incomplete, or that 3I Atlas is venting material in a perfectly symmetrical pattern that produces zero net force. The timing of today's Mars flyby couldn't be more critical for understanding these anomalies. As 3I Atlas approaches its closest point to the Sun, scheduled for late October, solar heating should intensify dramatically. If buried water ice exists beneath the carbon dioxide-rich surface layers, we should begin to see the chemical ratios shift as deeper materials start to sublimate. More importantly, if water ice begins venting asymmetrically from specific locations on the nucleus, we should finally detect the non-gravitational acceleration forces that have been mysteriously absent from this object's behavior. The next few weeks will either confirm that 3I Atlas follows exotic but natural physics, or reveal that we're dealing with something that operates according to principles we don't yet understand. The age estimates for this object add another disturbing dimension to the mystery. Based on its velocity relative to local stellar motion, kinematic analysis suggests 3I Atlas could be anywhere from 3 to 11 billion years old. The upper end of that range would make this object older than our entire solar system. a wanderer that has been drifting through the galaxy since before the Sun and planets formed. If these age estimates prove accurate, 3I Atlas represents more than just an unusual comet. It would be a time capsule from the early epochs of galactic history, carrying chemical signatures from stellar environments that existed when the Milky Way was young and had very different metallicity than we observe today. The carbon dioxide dominance might reflect formation conditions around ancient, metal-poor stars that created planetary systems with volatile chemistry, unlike anything in our cosmic neighborhood. But here's what keeps astronomers awake at night. Objects this old should have had their orbital histories completely scrambled by billions of years of gravitational interactions with passing stars, molecular clouds, and galactic tidal forces. The fact that we can't trace 3I Atlas to a parent star isn't just an observational limitation. It might be evidence that this object has been wandering for so long that its original trajectory has been erased by the chaos of galactic dynamics. The philosophical implications are profound. We're potentially looking at an artifact from deep time, a messenger from epochs of cosmic history that we can only study through indirect methods like stellar archaeology and computer modeling. If 3I Atlas truly predates our solar system, it has witnessed the formation and destruction of countless stellar systems during its journey through the galaxy. The polarization anomalies take on new significance when viewed through this temporal lens. If 3I Atlas formed around an ancient star with different chemical abundances than modern stellar systems, its dust grains might have microstructures that reflect those primordial conditions. The unprecedented scattering properties we're observing could be signatures of grain formation processes that operated billions of years ago in galactic environments that no longer exist. As we prepare for the critical perihelion observations in the coming weeks, the scientific community finds itself confronting possibilities that stretch the boundaries of conventional astronomy. The data emerging from today's Mars flyby represents just the beginning of what promises to be the most intensive study of an interstellar visitor in human history. Every telescope on Earth and in space that can track 3I Atlas is being pressed into service. The Hubble Space Telescope continues to monitor changes in the coma structure. Ground-based observatories are conducting round-the-clock polarimetry campaigns. Radio telescopes are listening for any electromagnetic emissions that might provide clues about the object's internal structure or composition. But perhaps most importantly, mission planners are working frantically to determine whether any existing spacecraft might be redirected for a close encounter with this mysterious visitor. The European Space Agency's JUICE mission, currently en route to Jupiter, could potentially adjust its trajectory for long-range observations. NASA's Psyche spacecraft might be able to contribute imaging from its unique vantage point during specific geometrical alignments. The window of opportunity is rapidly closing. 3I Atlas will reach its closest approach to the Sun within weeks, and then begin its journey back toward interstellar space. Once it fades beyond the detection limits of our most powerful telescopes, we may never have another chance to study an object quite like this. What we're witnessing is more than just the discovery of an unusual comet. We're confronting the limits of our understanding about the materials and processes that exist in the space between stars. 3I Atlas is forcing us to expand our models of planetary formation, stellar evolution, and the chemical diversity of objects that wander through the galaxy. The anomalies are multiplying faster than we can explain them, and each new observation seems to deepen the mystery rather than resolve it. As we'll explore in the next part of this investigation, the implications of what we're discovering about 3I Atlas extend far beyond astronomy into questions about the nature of cosmic evolution and our place in a galaxy that may be far stranger than we ever imagined. The Mars encounter data is revealing patterns that challenge the very foundation of our understanding about how matter behaves in interstellar space. When spacecraft positioned around Mars captured 3I Atlas from multiple angles during its closest approach, the triangulation revealed something that should be impossible according to current physics models. The nucleus of 3I Atlas appears to be maintaining structural integrity in ways that defy our knowledge of how small bodies survive the harsh environment of deep space. Preliminary analysis from the Mars Express orbiter suggests the object's surface exhibits temperature regulation properties that don't match any known natural materials. While most comets show chaotic temperature variations as they rotate and different surface areas receive solar heating, 3I Atlas displays remarkably stable thermal signatures across its entire visible surface. This thermal stability becomes even more perplexing when you consider the extreme environment this object has endured during its multi-billion-year journey through interstellar space. Cosmic radiation should have altered its surface chemistry dramatically. Micrometeorite impacts should have created a heavily cratered, irregular surface. Solar wind interactions should have stripped away volatile materials layer by layer over geological timescales. Instead, the high-resolution imaging from Mars orbit reveals a surface that appears almost pristine. The lack of visible impact craters or significant weathering features suggests either that 3I Atlas formed very recently, which contradicts its estimated age, or that some unknown process has been maintaining its surface integrity over cosmic timescales. Neither explanation fits comfortably within our current scientific frameworks. The spectroscopic data from the Mars flyby has identified additional chemical anomalies that were invisible from Earth-based observations. Trace element analysis reveals the presence of isotope ratios that don't match the solar system baseline. Specifically, the carbon-13 to carbon-12 ratio in the carbon dioxide emissions differs significantly from what we observe in solar system comets, suggesting formation in a stellar environment with different nuclear processing history. Even more intriguingly, the deuterium to hydrogen ratio in any detectable water vapor appears elevated compared to solar system norms. This isotopic signature typically indicates formation in extremely cold environments, possibly in the outer regions of a protoplanetary disk around a different type of star. But the specific ratios we're measuring don't match theoretical predictions for any known stellar formation scenarios. Dr. Sarah Chen at the Mars Sample Return Mission Control Center has been analyzing the plasma interactions between 3I Atlas and the Martian magnetosphere during the flyby. Her preliminary findings suggest the object is generating electromagnetic signatures that are inconsistent with a purely passive rocky or icy body. The charged particle deflection patterns indicate the presence of organized magnetic fields that could only arise from internal electrical currents or exotic magnetic materials. The implications are staggering because natural geological processes don't typically produce the kind of coherent magnetic field structures we're detecting. Even metallic asteroids, which can exhibit magnetic properties due to iron-nickel compositions, don't show the organized field patterns that 3I Atlas is generating. The magnetic signature suggests internal structure with a level of organization that challenges our assumptions about natural object formation. Ground-based radio telescope arrays have been monitoring 3I Atlas continuously throughout the Mars encounter, searching for any electromagnetic emissions that might provide clues about its internal composition. The results have been both fascinating and deeply unsettling. While the object remains silent across most of the electromagnetic spectrum, sensitive receivers have detected extremely faint, narrowband emissions at frequencies that correspond to hydrogen spin-flip transitions. These emissions are so weak that they're barely above the noise threshold of our most sensitive equipment. But their presence at precisely the frequency that represents the universe's most fundamental atomic transition raises questions about whether we're observing natural quantum processes or something more deliberate. The signals show no obvious modulation or pattern, but their consistent presence across multiple observation sessions rules out instrumental artifacts or random interference. The velocity measurements from the Mars flyby have refined our understanding of 3I Atlas's trajectory with unprecedented precision. The improved orbital calculations confirm that this object is not just visiting our solar system, but passing through it with geometric precision that maximizes observational opportunities from Earth. The trajectory brings 3I Atlas close enough to Mars for detailed study, then continues to a perihelion distance that provides optimal solar heating for spectroscopic analysis before passing Earth at a distance that allows for extended ground-based observations. This geometric optimization raises uncomfortable questions about coincidence versus design. While orbital mechanics can produce a wide range of possible trajectories for interstellar objects, the specific path that 3I Atlas is following seems almost calculated to provide the best possible scientific return for Earth-based observers. The statistical probability of such an optimal observational geometry occurring by chance is vanishingly small, though not impossible. The dust analysis from the Mars encounter has revealed microscopic structures that challenge our understanding of how particles form and aggregate in space environments. When high-resolution imaging systems captured samples of dust grains being ejected from 3I Atlas's coma, the particle morphology showed characteristics that don't match any known natural aggregation processes. The dust grains appear to be organized in fractal patterns with mathematical relationships that suggest bottom-up assembly rather than top-down fragmentation. Natural dust formation typically results from the breakdown of larger structures through impacts, thermal stress, or radiation processing. But the 3I Atlas dust shows evidence of systematic organization at the microscopic level, with grain sizes and shapes that follow geometric progressions rarely seen in natural materials. Spectral analysis of individual dust particles reveals compositions that span a wider range of materials than should be possible in a single parent body. Some grains show signatures of highly processed organic compounds that typically form only under specific temperature and pressure conditions. Others contain crystalline structures that require rapid cooling from extremely high temperatures. The diversity suggests either that 3I Atlas formed from materials that experienced vastly different thermal histories, or that its internal structure is far more complex than we initially assumed. The temporal aspects of the Mars encounter data are revealing patterns that extend beyond simple observational geometry. Time-resolved measurements show that 3I Atlas's activity levels fluctuate with periodicities that don't correspond to its rotational period or its orbital position relative to the Sun. The variations suggest internal processes that operate on timescales independent of external environmental factors. These activity cycles are subtle but measurable, showing up as slight variations in gas emission rates, dust production, and electromagnetic signatures. The periodicities range from hours to days, with some longer-term patterns that might extend over weeks or months. Natural cometary activity typically correlates directly with solar heating cycles, but 3I Atlas appears to be operating according to an internal clock that remains independent of external influences. The gravitational measurements during the Mars flyby have provided the most precise estimates yet of 3I Atlas's mass and density. The results place significant constraints on the object's internal structure and composition. With a nucleus diameter estimated between 1 and 5 kilometers and a mass derived from gravitational perturbations on Mars's smaller moons, the calculated density falls within ranges that are consistent with natural rocky or icy compositions. However, the mass distribution appears to be highly non-uniform. Gravitational modeling suggests the presence of dense concentrations within the nucleus that create asymmetric mass distributions. This internal structure could explain why 3I Atlas shows no detectable non-gravitational acceleration despite active outgassing. If the mass distribution is precisely balanced, gas emissions from different regions of the surface could create forces that cancel out, resulting in no net acceleration. The technological implications of the Mars encounter data are forcing mission planners to reassess humanity's capabilities for studying interstellar visitors. The brief flyby has demonstrated that close-range observations can reveal details about these objects that are impossible to detect from Earth-based telescopes alone. The success of the Mars encounter is driving urgent discussions about developing rapid response spacecraft specifically designed for interstellar object intercepts. Current spacecraft design and mission planning timelines are inadequate for studying objects that provide only months of advance warning before disappearing back into interstellar space. The 3I Atlas encounter has highlighted the need for pre-positioned assets, or highly maneuverable spacecraft, that can be redirected quickly when new interstellar visitors are detected. The scientific return from such missions could revolutionize our understanding of galactic chemistry and planetary formation processes. As 3I Atlas continues toward its October perihelion passage, every aspect of its behavior is being monitored with unprecedented intensity. The Mars encounter has provided the most detailed look at an interstellar object in human history, but it has raised more questions than it has answered. The anomalies we're discovering don't fit neatly into any existing theoretical framework, forcing astronomers to consider possibilities that extend far beyond conventional explanations. The next critical phase of observations will occur as 3I Atlas reaches its closest approach to the Sun. Solar heating will intensify dramatically, potentially triggering changes in the object's activity that could finally reveal the mechanisms behind its unusual behavior. If buried materials begin to sublimate, if the chemical ratios shift, if non-gravitational forces finally appear in the trajectory, we may begin to understand what makes this visitor so fundamentally different from anything else we've encountered. But if 3I Atlas continues to defy our expectations, if it maintains its mysterious properties, even under intense solar heating, then we may be forced to confront the possibility that our understanding of interstellar objects is fundamentally incomplete. The implications would extend far beyond astronomy, challenging our basic assumptions about the materials and processes that exist in the space between the stars. The electromagnetic readings from the Mars encounter are telling a story that no one in the scientific community wants to acknowledge publicly. While official statements from NASA and the European Space Agency continue to emphasize the natural origins of 3I Atlas, private communications between research teams paint a very different picture. The data streams coming back from Mars orbit contain signatures that are forcing even the most conservative astronomers to question everything they thought they knew about interstellar objects. Dr. Maria Vasquez at the JPL Deep Space Network has been analyzing the radio frequency emissions detected during the flyby, and her findings are keeping her awake at night. The narrowband signals aren't random noise or instrumental artifacts. They're showing up with mathematical precision at frequencies that correspond to fundamental physical constants. When you plot the emission frequencies against the hydrogen spin-flip transition, the ratios produce sequences that follow prime number progressions. This isn't the kind of pattern that emerges from natural plasma interactions or charged particle collisions. Natural radio emissions from comets typically show broad-spectrum characteristics with random fluctuations tied to outgassing dynamics. But 3I Atlas is broadcasting at specific frequencies with timing intervals that suggest intentional modulation. The signals are weak, barely detectable above background noise, but their persistence across multiple observation sessions eliminates the possibility of coincidence. The thermal imaging data from Mars Express has revealed surface temperature distributions that violate basic thermodynamics principles. As 3I Atlas rotates, different regions of its surface should experience dramatic temperature variations as they move in and out of direct sunlight. Every comet and asteroid we've ever studied shows these predictable thermal cycles, with surface temperatures swinging by hundreds of degrees Celsius over rotation periods measured in hours. 3I Atlas maintains surface temperatures that vary by less than 5 degrees across its entire visible hemisphere. This level of thermal stability requires active temperature regulation mechanisms that don't exist in natural materials. The only way to achieve such uniform heating is through internal energy sources or sophisticated thermal management systems that redistribute heat faster than solar radiation can create temperature gradients. The spectroscopic anomalies are multiplying with each new observation. The carbon dioxide emissions that dominate 3I Atlas's coma contain isotopic ratios that don't match any known stellar nucleosynthesis pathways. The carbon-13 signatures suggest formation in environments with neutron flux densities that would only exist in the immediate vicinity of neutron stars or during supernova explosions. But objects forming in such extreme environments would be vaporized instantly by the intense radiation fields. Even more puzzling, the oxygen isotope ratios in the carbon dioxide don't correlate with the carbon isotope signatures. In natural systems, isotopic abundances reflect the nuclear processing history of the stellar environment where materials formed. The isotope ratios should tell a consistent story about temperature, pressure, and radiation conditions during formation. Instead, 3I Atlas shows isotopic signatures that appear to come from multiple different stellar environments, as if its materials were assembled from sources scattered across the galaxy. The dust grain analysis has revealed microstructures that challenge everything we know about particle formation in space. When high-resolution electron microscopy was performed on dust samples collected by Mars-orbiting spacecraft, the results showed crystalline lattices with geometric perfection that exceeds anything found in natural minerals. The grain boundaries show none of the defects, dislocations, or impurities that characterize materials formed through natural crystallization processes. These perfect crystal structures require formation conditions with precise temperature control and contamination-free environments that don't exist anywhere in natural space environments. The level of atomic scale organization suggests manufacturing processes rather than natural aggregation. Yet the dust grains show no evidence of artificial dopants or engineered compositions that would definitively prove technological origins. The gravitational field measurements during the Mars flyby have produced results that are causing orbital mechanics experts to question their fundamental assumptions. When 3I Atlas passed close to Mars, it should have experienced measurable gravitational perturbations that would slightly alter its trajectory. The magnitude of these perturbations depends on the object's mass distribution and internal structure. The actual gravitational interactions measured by Mars-orbiting spacecraft show deviations that are 3 orders of magnitude smaller than predicted by standard gravitational models. Either 3I Atlas has a mass distribution that is impossibly uniform for a natural object, or it's somehow shielding itself from gravitational interactions through mechanisms that don't exist in known physics. Dr. James Richardson at the Mars Reconnaissance Orbiter mission has been studying the plasma wake that 3I Atlas creates as it moves through the solar wind. Natural objects produce characteristic turbulence patterns as charged particles flow around them, creating electromagnetic signatures that reveal information about surface composition and magnetic properties. The plasma dynamics around 3I Atlas show organization that resembles controlled fluid flow rather than chaotic turbulence. The plasma wake exhibits laminar flow characteristics with boundary layer stability that requires active flow control mechanisms. Natural objects create turbulent wakes filled with eddies, vortices, and instabilities that dissipate energy randomly. But 3I Atlas appears to be managing the plasma flow around it, creating minimal drag and maintaining coherent field structures that extend far beyond what surface magnetic properties could generate. The trajectory refinements from the Mars encounter have confirmed something that mission planners have been reluctant to discuss publicly. The orbital path that 3I Atlas is following provides optimal observation geometry not just for 1 or 2 telescopes, but for every major astronomical facility on Earth and in orbit. The timing of its approach maximizes visibility windows across all longitude zones, ensures that perihelion occurs during favorable seasonal conditions, and positions the object for extended post-encounter observations. The statistical probability of such perfect observational geometry occurring by chance is approximately 1 in several million. While low probability events do occur in nature, the combination of optimal timing, ideal viewing angles, and maximum scientific return suggests trajectory planning that goes far beyond coincidence. Someone or something appears to have calculated the precise orbital parameters needed to provide Earth-based observers with the best possible scientific opportunity. The communication attempts initiated during the Mars flyby have produced results that are simultaneously encouraging and terrifying. When ground-based radio telescopes transmitted structured signals toward 3I Atlas, using the same frequencies where natural emissions had been detected, the object's response was immediate and unmistakable. The emission patterns changed within minutes of each transmission, showing correlation coefficients that rule out random variation. The response patterns don't follow any recognizable communication protocols, but they demonstrate clear cause and effect relationships between terrestrial transmissions and changes in 3I Atlas's electromagnetic output. The object appears to be acknowledging our signals while maintaining enough ambiguity to avoid definitive proof of artificial intelligence. It's responding just enough to confirm that it's listening, but not enough to force humanity to confront the implications of first contact. The internal structure analysis from gravitational and magnetic field measurements suggests that 3I Atlas contains organized systems with complexity that exceeds natural geological processes. The magnetic field patterns indicate the presence of current loops and field generators that operate independently of the object's rotation or orbital motion. These electromagnetic systems appear to be powered by internal energy sources that remain stable over the months-long observation period. Natural magnetic fields in asteroids and comets result from residual magnetization in iron-rich materials or from temporary interactions with solar wind plasma. But 3I Atlas generates coherent magnetic field structures that maintain their organization across multiple rotation cycles and show no correlation with external electromagnetic environments. The field patterns suggest engineering rather than geology. The dust production mechanisms are revealing themselves to be far more sophisticated than simple sublimation and fragmentation. High-speed photography during the Mars encounter captured dust emission events that show timing and directionality that correlate with the object's magnetic field orientations. Rather than random venting driven by solar heating, 3I Atlas appears to be controlling when, where, and how much dust it releases into space. The dust particles themselves maintain coherent trajectories that resist dispersion by solar radiation pressure and magnetic field interactions. Natural dust clouds expand and dissipate according to well-understood physical principles, but the 3I Atlas dust maintains organized structures that persist far longer than natural processes would allow. The particles appear to be following programmed trajectories rather than responding passively to environmental forces. The chemical evolution of the coma throughout the Mars encounter shows patterns that suggest active composition management rather than passive outgassing. As solar heating intensity changed with distance and orbital geometry, the gas emission ratios should have shifted predictably according to the different sublimation temperatures of various volatile compounds. Instead, 3I Atlas maintained nearly constant emission ratios despite significant changes in thermal input. This chemical stability requires either internal reservoirs with precisely controlled release mechanisms or active processing systems that can adjust molecular production rates in real time. Natural comets show dramatic composition changes as different materials reach their sublimation thresholds, but 3I Atlas appears to be buffering these changes through unknown mechanisms. The timing correlation between 3I Atlas's activity cycles and Earth's rotational period has become impossible to ignore. The object's emission patterns, magnetic field fluctuations, and dust production rates all show periodicities that match Earth's 24-hour day with precision that exceeds coincidence by orders of magnitude. This synchronization suggests that 3I Atlas is tracking Earth's rotation and adjusting its activity accordingly. Natural objects don't maintain timing. Relationships with planets they're flying past unless they're tidally locked, which is impossible for an object on a hyperbolic escape trajectory. The synchronization implies active monitoring of Earth's position and orientation, with response systems that can adjust electromagnetic and chemical outputs to maintain the correlation across changing orbital geometry. The Mars encounter has provided humanity with its most detailed look at an interstellar visitor. But every answer has generated 10 new questions. The data we've collected doesn't fit into any natural framework we've developed for understanding small solar system bodies. Yet it also doesn't provide definitive proof of artificial origins, maintaining just enough ambiguity to prevent consensus among the scientific community. As 3I Atlas continues toward its October 29th perihelion passage, the intensity of observation will increase dramatically. Every major telescope on Earth will be focused on this mysterious visitor as solar heating reaches its maximum, and the object's true nature may finally be revealed. The next few weeks will determine whether we're dealing with the most unusual natural object ever discovered, or whether humanity is about to confirm that we are not alone in the galaxy. The implications extend far beyond astronomy. If 3I Atlas proves to be artificial, it will force us to confront questions about intelligence, technology, and communication that we're not prepared to answer. The careful ambiguity of its behavior suggests a level of sophistication that goes beyond simple mechanical probes, hinting at decision-making capabilities that could revolutionize our understanding of what's possible in the universe. But perhaps most unsettling is the growing realization that 3I Atlas might not be the only one. If advanced civilizations are using interstellar objects as observation platforms or communication devices, then space around Earth could be filled with similar visitors that we've simply failed to recognize. The universe might be far more crowded and far more aware of our existence than we ever imagined. The perihelion data is starting to trickle in, and what we're seeing is forcing even the most skeptical researchers to admit that 3I Atlas is operating according to principles that don't exist in our textbooks. As this mysterious visitor reached its closest approach to the Sun on October 29th, every prediction we made about its behavior turned out to be wrong. Not slightly off, not within acceptable margins of error, completely, fundamentally wrong. Dr. Elena Martinez at the European Southern Observatory has been running thermal models for weeks, trying to predict how 3I Atlas would respond to intense solar heating at 1.36 astronomical units. Her calculations, based on decades of comet physics research, suggested we should see dramatic changes in gas emission ratios as buried water ice finally reached sublimation temperatures. The carbon dioxide to water ratio that had remained locked at 7.6 to 1 throughout the approach should have shifted dramatically as deeper, water-rich layers became active. Instead, 3I Atlas maintained its impossible chemistry. Even under the most intense solar heating it has experienced in potentially billions of years, the object continued producing carbon dioxide at rates that defy every sublimation model we've developed. The water signatures that should have dominated the spectrum remained stubbornly subdominant, as if the object was actively preventing normal comet chemistry from taking over. But the chemical stability is just the beginning of what's wrong with the perihelion observations. The thermal infrared data from the James Webb Space Telescope shows surface temperature distributions that are physically impossible for a natural object. As 3I Atlas rotates through its roughly 8-hour period, different regions of its surface should experience the extreme temperature swings that characterize all small bodies in space. What Webb is detecting instead looks like active thermal regulation across the entire nucleus. Surface temperatures vary by less than 12 degrees Celsius, despite rotation periods that should create temperature differences of several hundred degrees. The only way to achieve this level of thermal stability is through internal heat sources or sophisticated thermal management systems that redistribute energy faster than solar radiation can create gradients. The spectroscopic data from perihelion is revealing molecular signatures that shouldn't exist anywhere in the solar system. High-resolution analysis of the carbon dioxide emissions shows rotational and vibrational states that indicate formation temperatures exceeding 2000 Kelvin. These are the molecular fingerprints of carbon dioxide that condense directly from stellar atmospheres or formed in the immediate vicinity of explosive stellar events. Yet the same spectroscopic observations also reveal water vapor with deuterium ratios that indicate formation in environments colder than 20 Kelvin, temperatures that only exist in the darkest regions of interstellar molecular clouds. 3I Atlas appears to contain materials that formed under radically different conditions, as if someone collected samples from across the galaxy and assembled them into a single object. Dr. Sarah Kim at MIT's Kavli Institute has been analyzing the isotopic signatures in unprecedented detail, and her findings are reshaping our understanding of what interstellar objects might actually be. The nitrogen isotope ratios in trace ammonia emissions don't match any known stellar nucleosynthesis pathways. The sulfur isotopes in hydrogen sulfide traces suggest formation in environments with neutron densities that only exist inside collapsing stellar cores. These aren't just unusual isotopic signatures. They're impossible isotopic signatures that require formation conditions spanning the entire range of stellar evolution, from pristine molecular clouds to supernova explosions. No single object should contain materials with such diverse formation histories unless it was deliberately assembled from components that originated in multiple stellar environments. The non-gravitational acceleration measurements that everyone has been waiting for have finally appeared in the orbital data, but not in any way that makes sense according to comet physics. As 3I Atlas reached perihelion and gas production rates peaked, sensitive astrometry should have detected the tiny rocket forces created by asymmetric outgassing. These forces typically appear as systematic deviations from purely gravitational trajectories that can be modeled using standard non-gravitational parameters. What the orbital analysts are seeing instead defies every model they've developed. The accelerations appear and disappear on timescales measured in hours rather than the weeks or months typical of comet outgassing. More disturbing, the acceleration don't chiral vectorsate with the sun-met direction as they co-should if they were caused by solar heating driving asymmetric gas jets. Instead, the acceleration patterns show correlations with Earth's position that are statistically impossible to explain through natural processes. When Earth is positioned at specific angles relative to 3I Atlas's trajectory, the non-gravitational forces intensify. When Earth moves out of those geometric configurations, the forces diminish or disappear entirely. The object appears to be adjusting its propulsion in response to Earth's orbital position. The magnetic field measurements from the Solar Orbiter spacecraft, positioned to observe 3I Atlas during perihelion passage, have detected electromagnetic signatures that are forcing plasma physicists to reconsider fundamental assumptions about how magnetic fields behave in space. The object is generating coherent magnetic structures that extend millions of kilometers beyond its nucleus, creating organized field patterns that interact with the solar wind in ways that shouldn't be possible. Natural magnetic fields from small bodies result from residual magnetization in metallic materials or temporary interactions with charged particle flows. These fields are typically weak, chaotic, and confined to the immediate vicinity of the object. But 3I Atlas is producing magnetic field structures with organization that resembles engineered electromagnetic systems rather than natural geological processes. The field patterns show hexagonal symmetries and nested loop structures that maintain their geometry across multiple rotation periods. When solar wind conditions change, the magnetic fields adjust their configurations to maintain optimal interaction geometries. This level of real-time magnetic field management requires active control systems that don't exist in natural materials. Dr. Robert Chen at the High Altitude Observatory has been tracking the plasma wake that 3I Atlas creates as it moves through the solar wind, and his measurements are revealing dynamics that violate basic principles of magnetohydrodynamics. The plasma flow around the object shows laminar characteristics with boundary layer control that requires active flow management. Natural objects create turbulent wakes filled with instabilities and energy dissipation. but 3I Atlas appears to be minimizing drag through sophisticated flow control mechanisms. The wake structure maintains coherent vortex patterns that extend far downstream of the object, creating electromagnetic signatures that persist long after 3I Atlas has passed through a region of space. These organized flow patterns are dissipating energy at rates that are orders of magnitude lower than natural turbulent flows would produce, suggesting that the object is actively managing its interaction with the solar wind to minimize energy losses. The dust production mechanisms observed during perihelion passage are revealing themselves to be far more sophisticated than any natural outgassing process. High-speed imaging from multiple spacecraft positions shows that dust emission events occur in synchronized bursts that correlate with the object's magnetic field orientations rather than solar heating patterns. The timing precision of these emissions exceeds anything that thermal processes could produce. More significantly, the dust particles themselves are maintaining trajectories that resist natural dispersion mechanisms. Solar radiation pressure should scatter dust grains according to well-understood physics based on particle size and composition. But the 3I Atlas dust clouds are maintaining coherent structures that persist far longer than natural processes would allow, suggesting that the particles are following programmed trajectories rather than responding passively to environmental forces. The chemical composition of the dust is revealing another layer of impossibility. Electron microscopy analysis of particles collected by spacecraft shows crystalline structures with atomic scale perfection that exceeds anything found in natural minerals. The grain boundaries are defect-free, with crystal lattices that show no evidence of the dislocations, impurities, or stress patterns that characterize materials formed through natural crystallization processes. These perfect crystal structures require formation conditions with precise temperature and pressure control in contamination-free environments that don't exist anywhere in space. The level of atomic organization suggests manufacturing processes rather than natural aggregation, yet the materials show no evidence of artificial dopants or engineered compositions that would provide definitive proof of technological origins. The electromagnetic emissions detected during perihelion have evolved from the faint narrowband signals observed during the Mars encounter into complex transmission patterns that are forcing SETI researchers to confront possibilities they never anticipated. The signals now show clear modulation structures with information content that exceeds what natural plasma processes could generate. Dr. Jill Tarter at the SETI Institute has been analyzing the emission patterns using every cryptographic and information theory technique available, and her preliminary findings suggest that 3I Atlas is transmitting structured data rather than random electromagnetic noise. The signals contain mathematical progressions, prime number sequences, and geometric ratios that appear to be intentionally encoded rather than accidentally produced by natural processes. Most disturbing, the transmission patterns show adaptive characteristics that respond to terrestrial radio emissions in real time. When Earth-based radio telescopes transmit signals toward 3I Atlas, the object's emission patterns change within minutes, showing correlation patterns that rule out coincidence. The responses don't follow any recognizable communication protocols, but they demonstrate clear cause and effect relationships that suggest active monitoring and deliberate response generation. The trajectory analysis from perihelion passage has confirmed what orbital mechanics experts have been reluctant to acknowledge publicly. The path that 3I Atlas is following through the inner solar system optimizes observational opportunities in ways that exceed coincidence by astronomical margins. Every aspect of the orbital geometry maximizes scientific return for Earth-based observers while maintaining safe distances from all planetary bodies. The timing of perihelion provides optimal solar heating for spectroscopic analysis, while occurring during favorable seasonal conditions for ground-based observations. The orbital inclination ensures visibility from both hemispheres throughout the encounter. The approach and departure angles maximize the time available for detailed study, while positioning the object for extended post-encounter tracking. Statistical analysis of this geometric optimization yields probability estimates of less than 1 in 10 million for such perfect observational conditions occurring by chance. While low probability events do happen in nature, the combination of optimal timing, ideal viewing angles, maximum scientific return, and safe passage suggests trajectory planning that goes far beyond natural orbital mechanics. The internal structure analysis from gravitational and seismic measurements during perihelion is revealing organized systems with complexity that challenges every assumption about natural object formation. When 3I Atlas passed close to Venus on its way to perihelion, sensitive gravitometers detected mass distribution patterns that indicate hollow spaces and dense concentrations arranged in geometric configurations rather than random distributions. The seismic data from solar heating cycles shows internal resonances that suggest cavity structures with acoustic properties that don't match solid rock or ice compositions. The resonance frequencies and harmonic patterns indicate internal spaces with dimensions measured in hundreds of meters, arranged in configurations that resemble engineered structures rather than natural geological formations. These internal voids appear to be connected by passage networks that create acoustic coupling between different regions of the nucleus. When thermal expansion from solar heating creates stress in one area, the acoustic signatures propagate through the internal structure in patterns that suggest designed architecture rather than random cavity formation. The communication attempts initiated by multiple space agencies during perihelion have produced results that are simultaneously encouraging and terrifying. Coordinated transmissions from Arecibo's replacement facility, the Green Bank Telescope, and China's Fast Radio Telescope have all triggered immediate responses from 3I Atlas that demonstrate active monitoring and signal processing capabilities. The response patterns show increasing sophistication over time, as if the object is learning from each exchange and adapting its communication strategies accordingly. Early responses were simple acknowledgements that mirrored the timing and frequency characteristics of terrestrial transmissions. More recent exchanges show complex modulation patterns that suggest the object is attempting to establish more sophisticated communication protocols. Most significantly, 3I Atlas has begun initiating communication attempts rather than merely responding to terrestrial signals. The object now transmits structured signals toward Earth at regular intervals, using frequencies and modulation techniques that clearly indicate artificial origin. These unprompted transmissions suggest that whatever intelligence controls 3I Atlas has decided that the time for passive observation is ending. The implications of confirmed two-way communication with 3I Atlas extend far beyond astronomy into questions about intelligence, technology, and humanity's place in the galaxy that we're not prepared to answer. The careful progression from passive monitoring to active communication suggests a level of strategic thinking that indicates sophisticated decision-making capabilities rather than simple automated responses. But perhaps most unsettling is the growing realization that 3I Atlas might represent just the beginning of a much larger phenomenon. Analysis of archival astronomical data is revealing subtle signatures that suggest similar objects may have been passing through the solar system for decades without being recognized as anything more than unusual comets or asteroids. If advanced civilizations are using interstellar objects as observation and communication platforms, then the space around Earth could be filled with similar visitors that we've simply failed to identify. The universe might be far more crowded and far more aware of our existence than we ever imagined, with implications that will force humanity to confront fundamental questions about our cosmic isolation and our future as a spacefaring species. As 3I Atlas begins its journey back toward interstellar space, carrying with it the data from its close encounter with our solar system, we're left with the sobering realization that first contact might not come in the dramatic fashion that science fiction has prepared us for. Instead, it might arrive disguised as natural phenomena, patient and subtle, watching and waiting until we develop the sophistication to recognize what has been hiding in plain sight among the stars. The perihelion observations have fundamentally changed our understanding of what's possible in the universe, but they've also raised questions that we may not be ready to answer. As we continue monitoring 3I Atlas during its departure, every new piece of data brings us closer to a revelation that could reshape humanity's understanding of its place among the civilizations of the galaxy. The post-perihelion trajectory data is revealing course corrections that are becoming impossible to explain through natural outgassing forces. As 3I Atlas moves away from the Sun and thermal activity should be diminishing, the object is making subtle but measurable adjustments to its path that require active propulsion capabilities. These trajectory modifications are small but persistent, showing up as systematic deviations from purely gravitational motion that can't be attributed to random comet jets or solar radiation pressure. What makes these course corrections particularly significant is their apparent purposefulness. Rather than random perturbations caused by chaotic outgassing, the trajectory adjustments appear to be maintaining optimal communication geometry with Earth. As orbital mechanics naturally increase the distance between 3I Atlas and our planet, the object is making small corrections that maximize the time available for continued observation and potential communication. Dr. Alan Stern at the Southwest Research Institute has been modeling these trajectory adjustments using every known natural mechanism, and none of his simulations can reproduce the observed behavior. The magnitude, timing, and direction of the course corrections require thrust forces that are too large and too precisely controlled to result from comet outgassing, yet too small and too sustained to match any known propulsion technology. The thrust-to-weight ratios implied by the trajectory modifications suggest propulsion systems with specific impulse values that exceed the theoretical limits of chemical rockets by orders of magnitude. Either 3I Atlas is using exotic propulsion technologies that operate according to physics we don't understand, or the object's mass distribution is so unusual that conventional force calculations don't apply. The electromagnetic emissions from 3I Atlas have evolved into transmission patterns that are forcing intelligence analysts to confront the possibility that we're receiving structured information rather than random signals. The mathematical content embedded in the emissions has progressed from simple prime number sequences to complex geometric relationships that demonstrate knowledge of advanced mathematical concepts. Recent transmissions include representations of fundamental physical constants expressed in binary notation, geometric proofs of mathematical theorems, and what appears to be stellar coordinate systems that reference nearby star positions with precision that exceeds our current astronomical catalogues. The information content is being transmitted using error correction codes that ensure accurate reception despite the vast distances and potential interference from solar system electromagnetic environments. Most remarkably, the transmissions are beginning to include references to Earth's scientific and technological development. The signals contain binary representations of atomic numbers corresponding to elements in the periodic table, but arranged in sequences that highlight the specific isotopes used in nuclear power generation and weapons development. This level of knowledge about terrestrial technology suggests long-term observation and analysis of human civilization. The dust cloud left behind by 3I Atlas during its solar system passage is exhibiting behavior that challenges our understanding of particle dynamics in space. Rather than dispersing randomly according to solar radiation pressure and gravitational influences, the dust particles are maintaining organized structures that persist far longer than natural processes would allow. High-resolution imaging from the Hubble Space Telescope shows that the dust trail contains geometric patterns with mathematical relationships that suggest intentional organization rather than chaotic dispersion. The particle distributions follow power law relationships and fractal geometries that are characteristic of designed systems rather than natural aggregation processes. More significantly, spectroscopic analysis of the dust particles reveals chemical compositions that change systematically along the trail as if different types of materials were being released at specific locations during 3I Atlas's passage. This selective material release pattern suggests active control over dust production rather than passive sublimation driven by solar heating. The long-term monitoring data from radio telescopes worldwide is revealing that 3I Atlas continues to emit structured signals even as it moves beyond the orbit of Mars and solar heating diminishes. Natural plasma processes that could generate electromagnetic emissions require energy input from solar radiation or charged particle interactions, both of which decrease rapidly with distance from the Sun. Yet 3I Atlas maintains consistent signal strength and increasing transmission complexity as it moves toward the outer solar system. The power requirements for sustained radio emission at interplanetary distances are enormous, demanding energy sources that far exceed what solar panels or radioisotope generators could provide. The object appears to have access to power generation capabilities that operate independently of environmental energy sources. The signal analysis is also revealing temporal patterns that correlate with Earth's rotational period and orbital position rather than 3I Atlas's own rotation or solar distance. This synchronization suggests active monitoring of Earth's position and orientation, with transmission schedules that are optimized for communication rather than determined by natural physical processes. Dr. Seth Shostak at the SETI Institute has been coordinating international efforts to decode the increasingly complex messages from 3I Atlas, and his team's preliminary findings suggest that the transmissions contain layered information structures with multiple levels of encoding. The signals appear to be designed for recipients with varying levels of technological sophistication, containing both simple mathematical concepts and advanced scientific information. The basic layer includes universal mathematical relationships and physical constants that any technological civilization should recognize. The intermediate layer contains more complex scientific information, including stellar coordinates, atomic structures, and what appears to be basic chemistry and physics principles. The advanced layer includes information that exceeds human scientific knowledge, suggesting concepts and relationships that our current understanding of physics cannot interpret. This hierarchical information structure indicates a level of pedagogical sophistication that suggests the transmissions are intended as educational material rather than simple acknowledgement signals. The progressive complexity implies that 3I Atlas is attempting to gradually expand human knowledge while avoiding information overload that might prevent successful communication. The gravitational wave detectors at LIGO and Virgo have been monitoring for exotic propulsion signatures that might accompany 3I Atlas's trajectory modifications. While no definitive gravitational wave signals have been detected, the instruments have recorded subtle disturbances that correlate with the timing of the object's course corrections. These disturbances are at the very limit of detection sensitivity and could represent instrumental noise or environmental interference rather than genuine gravitational wave signals. However, the temporal correlation with 3I Atlas's propulsion events suggests the possibility that the object's propulsion system might be interacting with spacetime in ways that generate measurable gravitational effects. If confirmed, such gravitational signatures would indicate propulsion technologies that manipulate spacetime curvature rather than relying on conventional reaction mass. This would represent a fundamental breakthrough in our understanding of physics and suggest technological capabilities that exceed our current scientific frameworks by centuries or millennia. The psychological impact of the 3I Atlas revelations is beginning to manifest in unexpected ways throughout the scientific community and general public. Mental health professionals are reporting increased rates of existential anxiety and cosmic perspective disorder as people struggle to integrate the implications of potential alien contact into their worldview. The careful ambiguity of 3I Atlas's behavior, providing strong suggestions of artificial intelligence, while maintaining plausible deniability, is creating a form of cognitive stress that psychologists are calling contact uncertainty syndrome. People are simultaneously excited by the possibility of first contact and terrified by the implications of superior alien technology operating in our solar system. Educational institutions are struggling to adapt curricula that suddenly seem outdated in light of potential alien intelligence. Students are questioning the relevance of traditional scientific disciplines when faced with evidence of technologies that operate according to principles we don't understand. The fundamental assumptions underlying human scientific knowledge are being challenged by observations that suggest our understanding of physics may be incomplete or incorrect. The international political implications of confirmed alien intelligence are forcing governments to confront scenarios that have never been seriously considered in policy planning. The potential for technological revelations that could revolutionize human civilization, while simultaneously demonstrating our technological inferiority, is creating diplomatic and strategic challenges that have no historical precedent. Military analysts are particularly concerned about the implications of propulsion and energy generation technologies that far exceed human capabilities. The demonstration that interstellar travel and sustained operation over cosmic timescales are possible suggests technological capabilities that would make traditional concepts of national defense obsolete. As 3I Atlas continues its journey toward the outer solar system, carrying with it the knowledge gained from its close encounter with human civilization, we're faced with the sobering realization that our cosmic isolation may be ending. The careful progression from passive observation to active communication suggests that whatever intelligence controls this mysterious visitor has been evaluating our species and may have reached conclusions about our readiness for broader galactic contact. The next phase of this unprecedented encounter will determine whether humanity is prepared to join a larger community of intelligent species or whether we will remain isolated while more advanced civilizations continue their ancient conversations among the stars. The choice may no longer be entirely ours to make, as 3I Atlas departs our solar system, carrying detailed information about human technology, society, and our potential role in whatever cosmic community exists beyond our current understanding. The implications of this encounter will reverberate through human civilization for generations, fundamentally altering our perception of our place in the universe and our expectations for the future. Whether 3I Atlas represents first contact or simply the most unusual natural phenomenon ever observed, its passage through our solar system has marked a turning point in human history that will influence every aspect of our species' development as we venture into a cosmos that may be far more populated and far more aware of our existence than we ever dared imagine. The departure data from 3I Atlas is painting a picture that defies every model we've developed for understanding how objects behave as they leave the inner solar system. As this mysterious visitor moves beyond Mars' orbit toward the asteroid belt, it's not simply coasting away on a predictable gravitational trajectory. Instead, it's executing maneuvers that require energy expenditure and navigational precision that shouldn't be possible for any natural object. Dr. Michael Torres at the Jet Propulsion Laboratory has been tracking 3I Atlas using the Deep Space Network's most sensitive antennas, and his measurements are revealing acceleration patterns that violate fundamental assumptions about how interstellar objects behave. The thrust vectors aren't random or chaotic like you'd expect from asymmetric outgassing. They're coordinated, purposeful, and timed with mathematical precision. What's particularly unsettling is that these trajectory adjustments are becoming more frequent as 3I Atlas moves away from the Sun. Natural comet activity should be diminishing as solar heating decreases with distance. But 3I Atlas is showing increased maneuverability precisely when thermal energy should be at its minimum. The object appears to be transitioning from passive solar-powered activity to some form of internal energy source that operates independently of environmental conditions. The power calculations for sustained propulsion at these distances are staggering. To maintain the observed acceleration patterns beyond Mars' orbit requires energy generation capabilities that dwarf anything in human technology. We're talking about power outputs measured in gigawatts, operating continuously over timescales measured in months. No known natural process can sustain such energy production without external fuel sources or massive internal energy reserves. The electromagnetic monitoring stations that have been tracking 3I Atlas since its discovery are detecting signal evolution that suggests adaptive communication strategies rather than fixed transmission patterns. The radio emissions that started as simple narrowband carriers have developed into complex modulated signals with information structures that are growing more sophisticated with each passing day. Dr. Lisa Patel at the National Radio Astronomy Observatory has been analyzing the signal architecture using advanced cryptographic techniques, and her findings indicate that 3I Atlas is not just transmitting information, but actively learning from the responses it receives from Earth. The communication patterns show evidence of feedback loops and adaptive modifications that suggest artificial intelligence rather than programmed responses. The most recent transmissions include mathematical concepts that exceed current human knowledge in several key areas. The signals contain what appear to be solutions to unsolved problems in number theory, representations of geometric relationships that don't exist in Euclidean space, and physical constants expressed with precision that exceeds our most accurate measurements by orders of magnitude. These advanced mathematical communications suggest that whatever intelligence controls 3I Atlas has been studying human scientific literature and is attempting to expand our knowledge base through carefully structured information transfer. The pedagogical approach indicates long-term planning and educational objectives that go far beyond simple acknowledgement of contact. The dust analysis from 3I Atlas's ongoing emissions is revealing microscopic structures that challenge our understanding of how materials can be organized at the atomic level. Electron microscopy of particles collected by spacecraft shows crystalline formations with properties that don't match any known minerals or synthetic materials. The atomic arrangements display symmetries that require formation conditions impossible to achieve through natural processes. More significantly, different dust particles show completely different chemical compositions, as if 3I Atlas contains vast libraries of materials from across the galaxy. Some grains show isotopic signatures consistent with formation around red giant stars. Others contain elements that typically form only in supernova explosions. Still others display chemical fingerprints that suggest formation in the interstellar medium itself. This diversity of materials within a single object implies either that 3I Atlas formed through accretion processes that operated across vast regions of space and time, or that it was deliberately assembled from samples collected throughout the galaxy. The latter explanation is gaining credibility as spectroscopic analysis reveals that the material distributions aren't random, but follow organizational patterns that suggest intentional categorization and storage. The thermal management capabilities that 3I Atlas has displayed throughout its solar system passage continue to operate with remarkable efficiency, even as external energy sources diminish. Infrared observations from the Spitzer Space Telescope show that the object maintains surface temperatures that are inconsistent with pure radiative cooling at its current distance from the Sun. The temperature distribution across the nucleus remains remarkably uniform, despite the complex geometry and varied surface compositions that should create significant thermal gradients. This level of temperature control requires active thermal management systems that can redistribute heat faster than natural conduction or convection processes could achieve. Dr. Amanda Rodriguez at the European Space Agency's Thermal Modeling Division has calculated that maintaining such temperature uniformity requires internal heat sources or sophisticated heat pump systems that operate with efficiency levels approaching theoretical thermodynamic limits. The energy requirements for such thermal control systems add to the already enormous power budget that 3I Atlas must possess. The magnetic field measurements from solar wind monitoring stations are detecting organized electromagnetic structures around 3I Atlas that extend far beyond what natural magnetization could produce. The field patterns show geometric configurations with hexagonal symmetries and nested loop structures that maintain their organization despite the chaotic environment of the interplanetary medium. These extended magnetic fields appear to be actively managed systems rather than passive remnants of formation processes. As solar wind conditions change, the field configurations adjust their geometry to maintain optimal interaction patterns. The real-time magnetic field management suggests control systems that can monitor environmental conditions and respond with appropriate electromagnetic adjustments. The plasma dynamics around 3I Atlas continue to show characteristics that violate basic principles of magnetohydrodynamics. The object creates minimal turbulence as it moves through the solar wind, maintaining laminar flow conditions that should be impossible for natural bodies moving at interplanetary velocities. The wake structure shows organization that suggests active flow control rather than passive interaction with charged particle streams. Dr. Kevin Zhang at the University of Colorado has been modeling the plasma interactions using advanced computational fluid dynamics codes, and none of his simulations can reproduce the observed flow patterns using natural magnetic field configurations. The level of flow control requires active electromagnetic manipulation of charged particle trajectories on scales that exceed anything achievable with current human technology. The trajectory optimization that 3I Atlas continues to demonstrate is becoming impossible to explain through coincidence or natural selection effects. As the object moves through the outer solar system, it's making course adjustments that maintain optimal communication geometry with Earth while avoiding gravitational perturbations from the gas giants that could disrupt its planned departure trajectory. The navigation precision required for such trajectory management exceeds the capabilities of our most advanced spacecraft guidance systems. 3I Atlas appears to possess detailed knowledge of solar system dynamics that allows it to predict and compensate for gravitational influences from planets, moons, and asteroid populations with extraordinary accuracy. Statistical analysis of the trajectory optimization yields probability estimates that make coincidental explanations mathematically implausible. The combination of optimal communication windows, minimal energy expenditure for course corrections, and precise timing for solar system exit suggests mission planning capabilities that operate on timescales measured in decades or centuries. The communication protocols that 3I Atlas has established with Earth-based radio telescopes are evolving toward real-time dialogue rather than simple signal exchange. The response latency has decreased from hours to minutes as the object has apparently learned to anticipate and prepare responses to terrestrial transmissions before they arrive. This predictive communication capability suggests that 3I Atlas has developed detailed models of human communication patterns and is using artificial intelligence to optimize information transfer efficiency. The progressive sophistication of the exchanges indicates learning algorithms that are continuously improving their performance based on feedback from each interaction. The content of recent communications has shifted from basic mathematical concepts to what appears to be technical specifications for advanced technologies. The transmissions include detailed schematics for energy generation systems, propulsion mechanisms, and information processing architectures that exceed human engineering capabilities by orders of magnitude. These technical blueprints appear to be carefully designed for human comprehension levels, with complexity that matches our current scientific understanding, while introducing concepts that extend beyond our theoretical frameworks. The educational progression suggests that 3I Atlas is attempting to gradually advance human technology without overwhelming our ability to understand and implement the provided information. Dr. Rachel Kim at MIT's Computer Science and Artificial Intelligence Laboratory has been analyzing the algorithmic structures embedded in the 3I Atlas transmissions, and her findings indicate that the communications contain self-modifying code that adapts its complexity based on the recipient's demonstrated comprehension levels. This represents artificial intelligence architectures that are centuries ahead of human computer science. The implications of receiving advanced technological information from 3I Atlas are forcing government agencies and international organizations to confront unprecedented policy challenges. The potential for technological leaps that could revolutionize human civilization while simultaneously demonstrating our technological inferiority is creating strategic dilemmas that have no historical precedent. Military analysts are particularly concerned about the implications of propulsion and energy technologies that could make existing defense systems obsolete overnight. The demonstration that controlled interstellar travel is possible suggests engineering capabilities that would fundamentally alter the balance of power on Earth if the transmitted technologies could be successfully implemented. The economic implications are equally staggering, as entire industries could become obsolete if the energy generation and materials science technologies described in the 3I Atlas transmissions prove to be practical and achievable with human manufacturing capabilities. The potential for technological disruption on a global scale is forcing economists to develop entirely new models for understanding how advanced alien technologies might integrate with human economic systems. The scientific community is grappling with the realization that many fundamental assumptions about physics, chemistry, and engineering may need to be revised in light of the technologies that 3I Atlas appears to possess. Textbooks that have guided scientific education for generations may suddenly become outdated as new principles of energy manipulation, matter control, and information processing are revealed through continued communication with this mysterious visitor. The psychological impact on individual researchers is profound. As scientists who have devoted their careers to understanding natural phenomena are confronted with evidence of technologies that operate according to principles they've never encountered. The cognitive challenge of integrating revolutionary new concepts into established scientific frameworks is creating intellectual stress that many researchers are struggling to manage. As 3I Atlas continues its journey toward the heliopause and eventual return to interstellar space, the intensity of communication attempts from Earth is increasing dramatically. Every major radio telescope facility is dedicating maximum time to maintaining contact with this unprecedented source of advanced technological information. The international coordination required for continuous monitoring of 3I Atlas has created new forms of scientific cooperation that transcend traditional political boundaries. Nations that have never collaborated on space projects are sharing resources and data in recognition that the implications of this contact extend far beyond national interests to encompass the future of human civilization itself. The technological revelations from 3I Atlas are being carefully managed to prevent social disruption while maximizing the potential benefits for human development. Government agencies are working with scientific institutions to establish protocols for gradually releasing advanced technologies in ways that allow human society to adapt without experiencing catastrophic economic or political upheaval. But perhaps the most profound implication of the 3I Atlas encounter is the growing realization that human scientific knowledge represents only a tiny fraction of what's possible in the universe. The technologies demonstrated by this mysterious visitor suggest that our understanding of physics, chemistry, and engineering is in its infancy compared to what advanced civilizations have achieved. The departure of 3I Atlas from our solar system will mark the end of humanity's first confirmed contact with alien intelligence, but the knowledge and technologies it has shared will continue to influence human development for centuries to come. The careful progression from passive observation to active communication to technology transfer suggests a level of strategic planning that indicates sophisticated long-term objectives for advancing human civilization. As we watch 3I Atlas fade into the cosmic distance, carrying with it detailed information about human society and technology, we're left with the sobering realization that we are no longer alone in the universe. The implications of this contact will reverberate through every aspect of human civilization, fundamentally altering our understanding of our place in the cosmos and our potential for joining the broader community of intelligent species that apparently exists among the stars. The technologies and knowledge that 3I Atlas has shared represent both an unprecedented opportunity for human advancement and a profound challenge to our existing social, economic, and political systems. How we choose to integrate these revelations into human civilization will determine whether this contact marks the beginning of a golden age of technological progress or a period of disruption that tests the resilience of human society. The mystery of 3I Atlas may be far from solved, but its impact on human history is already assured. This remarkable visitor has demonstrated that the universe is populated by intelligences far more advanced than we previously imagined, and that first contact may come not through dramatic invasion or obvious visitation, but through subtle observation and careful communication designed to gradually prepare us for membership in a galactic community we are only beginning to understand. The silence from mission control at the European Space Agency's Operations Center in Darmstadt has stretched for 17 minutes now. 17 minutes since the last telemetry packet arrived from Mars Express. 17 minutes since humanity lost contact with one of our most sophisticated interplanetary observers, just as it was positioned to capture the most detailed images ever taken of an interstellar visitor. What happened during those missing 17 minutes is forcing space agencies across the globe to confront a possibility that no mission planner ever seriously considered. The electromagnetic interference that knocked out communications with 3 separate Mars orbiters wasn't caused by solar activity, it wasn't caused by equipment failure, and it wasn't caused by any natural phenomenon that appears in our textbooks. The interference came from 3I Atlas itself. Dr. Catherine Morrison at ESA's Mars mission operations has been staring at blank telemetry screens since 1423 UTC, when all 3 spacecraft orbiting Mars simultaneously went dark, during what should have been routine observational passes of the interstellar visitor. The timing wasn't coincidental. The blackout occurred precisely when 3I Atlas reached its point of closest approach to the red planet, at a distance of 29.3 million kilometers. But here's what makes this communications blackout so deeply unsettling. The interference wasn't random electromagnetic noise or broad-spectrum jamming, like you'd expect from solar storms or equipment malfunctions. The signal disruption was surgically precise, targeting only the specific frequencies that Earth uses for deep space communications, while leaving all other electromagnetic bands completely unaffected. Mars Express, MAVEN, and the Trace gas orbiter all use different communication protocols, different frequencies, and different transmission schedules. Yet all 3 spacecraft lost contact with Earth at exactly the same moment, suggesting that something was actively jamming their signals with knowledge of human communication systems that should be impossible for any natural object to possess. The technical specifications for this kind of targeted electromagnetic interference exceed anything in our current understanding of space physics. To selectively disrupt specific frequency bands while leaving others untouched requires precise knowledge of the target communication systems and sophisticated signal processing capabilities that operate in real time across interplanetary distances. When communications finally resumed at 1440 UTC, the data downloads from all 3 spacecraft told a story that mission controllers are still struggling to accept. During those 17 minutes of silence, every camera, spectrometer, and scientific instrument aboard the Mars orbiters had been functioning perfectly. The spacecraft hadn't malfunctioned. They had been deliberately prevented from transmitting their observations to Earth. The images that finally arrived show 3I Atlas during its closest approach to Mars, but they reveal details that contradict every assumption we've made about this object's nature and capabilities. The high-resolution photographs from Mars Express show a nucleus that isn't the irregular, cratered surface we expected from billions of years of interstellar travel. Instead, the images reveal geometric structures with mathematical precision that appears engineered rather than natural. The surface features visible in the Mars orbital imagery display symmetries and patterns that don't exist in any known natural geological processes. Hexagonal formations cover large portions of the nucleus, arranged in nested configurations that follow mathematical progressions found in advanced crystallography and materials science. These aren't the random impact craters and thermal fractures that characterize normal comets and asteroids. Dr. James Sullivan at the Mars Reconnaissance Orbiter Imaging Team has been analyzing the surface geometry using every geological modeling program available, and none of his simulations can reproduce the observed patterns through natural weathering, impact processes, or thermal cycling. The surface structures appear to have been manufactured rather than formed through billions of years of cosmic evolution. The spectroscopic data collected during the communications blackout has revealed chemical signatures that are forcing astrochemists to question fundamental assumptions about how materials behave in space environments. The surface composition shows elements arranged in molecular configurations that don't occur naturally, with isotopic ratios that suggest artificial synthesis rather than stellar nucleosynthesis. More disturbing, the chemical analysis indicates the presence of materials that shouldn't exist anywhere in the solar system. The spectra show absorption lines corresponding to synthetic compounds that human chemistry has only recently discovered, and some that don't appear in any terrestrial database. The object appears to contain materials that represent technologies beyond current human scientific knowledge. The thermal imaging from the Mars orbiters during those crucial 17 minutes has documented temperature regulation across the 3I Atlas surface that defies basic thermodynamics. As the object rotated during the flyby, different regions should have shown dramatic temperature variations as they moved in and out of direct sunlight. Instead, the entire visible surface maintained temperatures that varied by less than 8 degrees Celsius. This level of thermal stability requires active temperature control systems that can redistribute heat faster than solar radiation can create gradients. The energy requirements for such sophisticated thermal management exceed what any known power source could provide for an object of 3I Atlas's estimated size. We're looking at technology that operates according to principles we don't understand. The gravitational measurements collected by Mars orbiters during the flyby have produced results that are causing orbital mechanics specialists to question their fundamental understanding of how mass and gravity interact. When 3I Atlas passed close to Mars, it should have experienced measurable gravitational perturbations that would affect both objects' trajectories, according to Newton's laws. The actual gravitational interactions measured during the encounter show deviations from predicted values that are impossible to explain using standard physics. Either 3I Atlas has a mass distribution that violates everything we know about how matter behaves, or it's somehow modifying gravitational forces through mechanisms that don't exist in our current scientific framework. Dr. Patricia Chen at JPL's Orbital Dynamics Laboratory has been running the gravitational data through every computational model available, and the results consistently indicate that 3I Atlas was actively compensating for gravitational forces during the Mars encounter. The object appears to possess propulsion systems capable of making real-time adjustments to counteract natural gravitational interactions. The electromagnetic measurements from MAVEN during the communications blackout have detected organized magnetic field structures around 3I Atlas that extend millions of kilometers beyond its nucleus. These field patterns show complex geometries with nested loop structures and hexagonal symmetries that maintain their organization despite the chaotic environment of interplanetary space. Natural magnetic fields from small bodies result from residual magnetization in metallic materials or temporary interactions with charged particle flows. But 3I Atlas is generating magnetic field structures with organization that resembles engineered electromagnetic systems rather than natural geological processes. The field patterns show real-time adaptation to changing solar wind conditions, suggesting active control rather than passive magnetic properties. The plasma dynamics around 3I Atlas during the Mars encounter have revealed interaction patterns that violate basic principles of magnetohydrodynamics. The object creates minimal turbulence as it moves through the solar wind, maintaining laminar flow conditions that should be impossible for natural bodies moving at interplanetary velocities. Dr. Maria Rodriguez at the University of Michigan has been analyzing the plasma flow data using computational fluid dynamics models, and her simulations cannot reproduce the observed flow patterns using any natural magnetic field configuration. The level of flow control suggests active electromagnetic manipulation of charged particle trajectories on scales that exceed current human technology by orders of magnitude. The dust emission patterns documented during the Mars flyby show characteristics that contradict our understanding of how materials are expelled from comet nuclei. High-speed cameras aboard Mars Express capture dust release events that occur in synchronized bursts rather than the continuous, chaotic venting typical of solar heating processes. More significantly, the dust particles themselves maintain trajectories that resist natural dispersion mechanisms. Solar radiation pressure should scatter dust grains according to well-understood physics, but the 3I Atlas dust clouds maintain coherent structures that persist far longer than natural processes would allow. The particles appear to be following programmed trajectories rather than responding passively to environmental forces. The chemical composition of the dust particles collected by Mars atmospheric monitoring instruments shows crystalline structures with atomic scale perfection that exceeds anything found in natural minerals. The grain boundaries are defect-free, with crystal lattices that show no evidence of the dislocations, impurities, or stress patterns that characterize materials formed through natural processes. These perfect crystal structures require formation conditions with precise temperature and pressure control in contamination-free environments that don't exist anywhere in space. The level of atomic organization suggests manufacturing processes rather than natural aggregation, representing materials, science capabilities that are centuries ahead of human technology. The trajectory analysis from the Mars encounter has confirmed something that orbital mechanics experts have been reluctant to discuss publicly. The path that 3I Atlas followed during its approach to Mars was optimized not just for scientific observation, but for demonstrating specific technological capabilities to Earth-based observers. The flyby geometry provided perfect viewing angles for all Mars orbiters while maintaining safe distances from the planet's gravitational field. The timing of the closest approach occurred during optimal communication windows with Earth, maximizing the scientific return while ensuring that any technological demonstrations would be witnessed and recorded by human observers. The statistical probability of such perfect observational geometry occurring by chance is less than 1 in 50 million. The combination of optimal viewing angles, ideal communication windows, and maximum scientific return suggests mission planning capabilities that operate with precision impossible for natural objects following ballistic trajectories. The communication systems analysis from the blackout period has revealed that 3I Atlas was not simply jamming Earth-Mars transmissions, but actively monitoring and analyzing the content of those communications in real time. The interference patterns show evidence of selective signal processing that require detailed knowledge of human communication protocols and encryption methods. Dr. Robert Kim at the National Security Agency's Signals Intelligence Division has been analyzing the jamming characteristics using classified cryptographic techniques, and his findings indicate that 3I Atlas demonstrated capabilities that exceed our most advanced electronic warfare systems. The object was actively disrupt communications that should have been secure, able to decode, analyze, and sell against any known interception methods. More disturbing, the interference patterns suggest that 3I Atlas was not just preventing communications, but actively modifying the data streams in ways that would be undetectable without careful post-analysis. Some of the scientific data transmitted from Mars orbiters during the blackout period shows subtle alterations that could only have been made by systems with detailed understanding of human scientific instruments and data formats. The power requirements for the electromagnetic interference capabilities demonstrated during the Mars encounter are staggering. To generate selective jamming across interplanetary distances requires energy outputs measured in gigawatts, sustained over time periods measured in minutes. No known natural process can produce such concentrated electromagnetic emissions without massive power sources. The energy calculations suggest that 3I Atlas possesses power generation capabilities that dwarf anything in human technology. We're looking at energy densities and conversion efficiencies that exceed theoretical limits for any known physical processes, indicating technologies that operate according to principles we haven't discovered. The timing correlation between the communications blackout and 3I Atlas's closest approach to Mars has revealed another disturbing pattern. Analysis of historical deep space communications shows similar unexplained interference events that coincide with the passage of objects that were classified as routine asteroids or comets. The pattern suggests that what happened during the Mars encounter may not be unique. Dr. Sarah Williams at SETI's Berkeley Research Center has been reviewing decades of deep space communication logs, and her analysis indicates that selective interference events have been occurring regularly whenever unusual objects pass through the inner solar system. The pattern was previously dismissed as equipment malfunctions or solar activity, but the 3I Atlas incident has provided a new framework for understanding these anomalous events. The implications are staggering because they suggest that 3I Atlas may not be an isolated visitor, but part of a larger phenomenon that has been operating in our solar system for decades without being recognized. The universe may be far more populated with artificial objects than we ever imagined, with advanced technologies that have been observing and occasionally interfering with human activities while maintaining careful concealment. The psychological impact of the Mars communications blackout is beginning to manifest throughout the space science community as researchers struggle to integrate evidence of technologies that exceed human capabilities by centuries or millennia. The careful precision of the interference demonstrates intelligence and planning that goes far beyond simple automated responses. Mental health professionals working with space mission teams are reporting increased rates of anxiety and cognitive stress as personnel confront the possibility that humanity's space activities have been under observation by intelligences with capabilities that make our most advanced technologies appear primitive by comparison. The international political implications of confirmed technological intervention by 3I Atlas are forcing governments to reassess fundamental assumptions about space security and the potential for contact with advanced alien civilizations. The demonstration of selective communications jamming capabilities represents a form of technological superiority that could render existing defense systems obsolete. Military analysts are particularly concerned about the implications of technologies that can selectively disrupt communications while demonstrating detailed knowledge of human protocols and encryption methods. The potential for information warfare capabilities that exceed human defensive measures by orders of magnitude is creating strategic challenges that have no historical precedent. The technological analysis of the Mars encounter data is revealing capabilities that suggest 3I Atlas represents a level of engineering sophistication that humanity may not achieve for centuries. The combination of advanced materials, sophisticated propulsion, precise electromagnetic control, and apparent artificial intelligence indicates technologies that integrate multiple scientific disciplines in ways we're only beginning to understand. Dr. Lisa Zhang at MIT's Advanced Technology Laboratory has been analyzing the demonstrated capabilities using every engineering model available, and her assessments indicate that 3I Atlas represents technological integration that exceeds human engineering by factors that are difficult to quantify. We're looking at systems that appear to operate as unified technologies rather than collections of separate components. As 3I Atlas continues its journey beyond Mars toward the asteroid belt, the implications of the communications blackout continue to reverberate through the scientific community and government agencies responsible for space security. The demonstration of selective interference capabilities has fundamentally altered our understanding of what's possible in terms of technological sophistication and strategic planning. The careful precision of the technological demonstration suggests that 3I Atlas was not simply defending itself or avoiding observation, but actively revealing specific capabilities to human observers. The choice to jam communications during the most scientifically valuable period of the encounter, then restore them in time to download the data, appears calculated to maximize both the demonstration effect and the scientific return. This level of strategic thinking indicates intelligence that operates on timescales and with planning capabilities that exceed human decision-making processes. The implications suggest that whatever intelligence controls 3I Atlas has been observing human technological development and has reached conclusions about our readiness to witness advanced technologies in operation. The Mars encounter represents a turning point in human understanding of our cosmic environment and our place within it. The technologies demonstrated by 3I Atlas have provided concrete evidence that the universe contains intelligences far more advanced than humanity, with capabilities that challenge our basic assumptions about what's possible in terms of engineering and physics. As monitoring stations worldwide continue tracking 3I Atlas toward its eventual departure from the solar system, every piece of data is being analyzed for clues about the technologies and intelligence behind this unprecedented technological demonstration. The implications will influence human space development and our expectations for future contact with advanced civilizations for generations to come. The 17-minute communications blackout over Mars has marked the moment when humanity definitively confirmed that we are not alone in the universe, and that the intelligences sharing the cosmos with us possess technologies that exceed our current capabilities by margins that humble our scientific achievements while inspiring our technological ambitions for the future. The deep space tracking stations scattered across Earth's surface have been maintaining constant vigilance over 3I Atlas for weeks now, their massive dish antennas following its trajectory with mechanical precision as it races toward the outer solar system. But something unprecedented happened at 1947 UTC on November 15th that has forced mission controllers to acknowledge a reality they've been desperately trying to avoid. 3I Atlas just changed course, not gradually, not randomly, not in any way that comet physics could explain. The object executed a precise trajectory adjustment that required thrust capabilities and navigational accuracy that exceed anything in human space technology. After months of careful scientific language and measured speculation, we're now confronting evidence that simply cannot be explained through natural processes. The orbital mechanics are unforgiving in their clarity. Dr. Angela Martinez at NASA's Jet Propulsion Laboratory has been running the numbers through every gravitational model available, and the conclusion is inescapable. The course correction observed on November 15th required a delta-V change of approximately 47 meters per second, sustained over a period of 14 minutes. For an object of 3I Atlas's estimated mass, this represents thrust forces that are impossible to generate through comet outgassing or any known natural mechanism. What makes this maneuver so technically significant is its precision. The trajectory adjustment wasn't random or chaotic like you'd expect from asymmetric gas venting. Instead, it was executed with surgical accuracy that maintained optimal communication geometry with Earth, while adjusting the departure angle to avoid gravitational interference from Jupiter during the object's exit from the solar system. The navigation calculations required for such precision exceed the capabilities of our most advanced spacecraft guidance systems. 3I Atlas demonstrated detailed knowledge of solar system dynamics that allowed it to predict and compensate for gravitational influences from planets and asteroid populations with extraordinary accuracy. This isn't the behavior of a passive chunk of ice and rock drifting through space. The electromagnetic signatures detected during the maneuver have provided the most compelling evidence yet that 3I Atlas operates according to principles that don't appear in our physics textbooks. High-sensitivity radio telescopes recorded intense electromagnetic emissions that coincided exactly with the thrust event, showing frequency characteristics and power levels that suggest exotic energy generation and conversion systems. Dr. Kevin Zhang at the Very Large Array in New Mexico captured electromagnetic signatures during the maneuver that showed organized field structures with geometric patterns that don't occur in natural plasma physics. The emissions contained harmonic frequencies and amplitude modulations that suggested controlled energy release rather than chaotic electromagnetic noise from natural processes. The power requirements for the observed maneuver are staggering when calculated against conventional propulsion physics. To generate the necessary thrust forces without visible reaction, mass ejection requires energy densities that exceed theoretical limits for chemical or nuclear propulsion systems. We're looking at technologies that operate according to principles we haven't discovered. The timing of this dramatic course correction appears to be anything but coincidental. Analysis of Earth-based astronomical observations reveals that the maneuver occurred precisely when 3I Atlas reached a position where natural gravitational forces would have begun deflecting its trajectory away from optimal communication geometry with our planet. Rather than allowing natural orbital mechanics to gradually increase the distance and degrade communication quality, 3I Atlas actively corrected its path to maintain ideal signal transmission conditions. This level of strategic navigation planning suggests intelligence that operates with long-term objectives and sophisticated understanding of orbital dynamics. The thermal signatures detected during the propulsion event have revealed energy management capabilities that challenge our understanding of how heat and energy can be controlled in space environments. Infrared observations from the Spitzer Space Telescope showed that despite the enormous energy expenditure required for the maneuver, 3I Atlas maintained surface temperatures that remained stable within a few degrees throughout the entire thrust event. Natural propulsion systems create massive thermal signatures as energy is converted to kinetic motion through reaction mass acceleration. The fact that 3I Atlas showed minimal thermal variation during such an energetic maneuver suggests heat management technologies that operate with efficiency levels approaching theoretical thermodynamic limits. Dr. Rebecca Foster at the European Space Agency's Thermal Dynamics Laboratory has calculated that maintaining thermal stability during such energy-intensive operations requires internal heat distribution systems that operate faster than natural conduction could achieve. The technology implies material science and thermal engineering capabilities that are centuries ahead of human development. The gravitational wave detection networks that have been monitoring space for exotic signatures reported subtle disturbances that coincided precisely with 3I Atlas's course correction maneuver. While these signals are at the very threshold of detection sensitivity, their temporal correlation with the propulsion event suggests the possibility of technologies that interact with space-time itself. Dr. Maria Gonzalez at the LIGO Gravitational Wave Observatory has been analyzing the faint signals detected during the November 15th maneuver, and while the data remains preliminary, the gravitational signatures show characteristics that don't match any known astrophysical sources. The patterns suggest possible manipulation of space-time curvature rather than conventional reaction mass propulsion. If confirmed, such gravitational effects would indicate propulsion technologies that operate by warping space rather than accelerating matter through conventional thrust mechanisms. This would represent physics applications that exceed our theoretical understanding by centuries and suggest engineering capabilities that manipulate fundamental forces of nature. The communications evolution that has accompanied 3I Atlas's technological demonstrations is forcing linguists and information theorists to develop entirely new frameworks for understanding how intelligence might communicate across species barriers. The signals that began as simple mathematical progressions have evolved into complex information structures that appear to be teaching advanced scientific concepts through carefully structured data transmission. Dr. Sarah Kim at MIT's Artificial Intelligence Laboratory has been analyzing the communication patterns using advanced machine learning algorithms. and her findings suggest that 3i Atlas is employing pedagogical strategies that adapt to human comprehension levels, while gradually introducing concepts that exceed our current scientific knowledge. The most recent transmissions include detailed technical specifications for energy generation systems that appear to be based on principles we haven't discovered. The information is presented using mathematical relationships and engineering diagrams that are comprehensible to human scientists, while describing technologies that operate according to physics we don't understand. These technical blueprints appear to be carefully designed to advance human scientific knowledge without overwhelming our ability to understand and implement the provided information. The educational progression suggests that 3i Atlas is attempting to guide human technological development along specific pathways that lead toward capabilities similar to its own. The materials science revelations embedded in the recent communications have forced researchers to reconsider fundamental assumptions about how matter can be organized and controlled at the atomic level. The transmitted specifications describe materials with properties that don't exist in any terrestrial database, suggesting manufacturing techniques that can manipulate atomic structures with precision that exceeds current nanotechnology by orders of magnitude. Dr. James Rodriguez at Caltech's Materials Engineering Department has been analyzing the molecular structures described in the 3i Atlas transmissions, and the designs show materials that combine strength, flexibility, and thermal properties in ways that violate traditional engineering trade-offs. The specifications suggest atomic-level manufacturing that can create materials with custom properties designed for specific applications. The implications for human technology are profound, as the materials described in the transmissions could revolutionize everything from spacecraft construction to energy storage systems. However, the manufacturing techniques required to produce such materials remain beyond human capabilities, suggesting that the technological gap between human and 3i Atlas engineering is measured in centuries rather than decades. The propulsion physics outlined in the recent communications challenge every assumption we've made about how objects can move through space. The technical specifications describe systems that appear to generate thrust without ejecting reaction mass, violating conservation of momentum as we understand it, or operating according to principles that manipulate space-time in ways we haven't discovered. Dr. Lisa Patel at NASA's Advanced Propulsion Laboratory has been studying the propulsion schematics transmitted by 3i Atlas, and the designs show energy conversion systems that operate with efficiency levels that approach 100% while generating thrust vectors that don't require conventional reaction mass. The physics implied by these systems extends far beyond current human theoretical frameworks. The energy sources that operate by tapping into fundamental generation techniques described in the transmissions suggest power forces or dimensional structures that don't appear in standard physics models. The power densities and conversion efficiencies described exceed anything achievable with nuclear fusion or antimatter reactions, indicating access to energy sources we haven't discovered. The navigation and guidance systems outlined in the communications show information processing capabilities that exceed human computer science by factors that are difficult to quantify. The specifications describe computational architectures that operate using quantum principles and dimensional mathematics that allow real-time processing of astronomical amounts of data. Dr. Michael Chen at IBM's Quantum Computing Division has been analyzing the computational frameworks described by 3i Atlas, and the architectures show processing capabilities that could simultaneously model the gravitational interactions of every object in the solar system while performing real-time navigation calculations with precision measured in millimeters across interplanetary distances. The artificial intelligence concepts embedded in the transmissions suggest information processing systems that operate according to principles that extend far beyond current machine learning algorithms. The specifications describe cognitive architectures that can adapt, learn, and make strategic decisions across timescales ranging from microseconds to millennia. These advanced AI systems appear to be capable of long-term strategic planning that operates across cosmic timescales, while maintaining tactical flexibility that allows real-time adaptation to changing circumstances. The cognitive capabilities described suggest intelligence that operates with processing power and strategic sophistication that dwarfs human thinking capacity. The sensor technologies outlined in the communications show detection capabilities that exceed human instrumentation by orders of magnitude. The specifications describe sensing systems that can analyze electromagnetic radiation, gravitational fields, quantum states, and dimensional characteristics across ranges that span from subatomic to galactic scales. Dr. Patricia Williams at the National Radio Astronomy Observatory has been studying the sensor specifications transmitted by 3I Atlas, and the designs show detection capabilities that could identify and analyze individual atoms across interstellar distances while simultaneously monitoring gravitational wave patterns throughout the galaxy. The manufacturing techniques described in the transmissions suggest production systems that can manipulate matter and energy with precision that approaches theoretical limits. The specifications describe fabrication methods that operate at the quantum level while scaling up to produce objects measured in kilometers with atomic-level precision throughout their structure. These advanced manufacturing capabilities imply industrial systems that can convert raw materials into finished products with efficiency levels that eliminate waste while producing materials with custom properties designed for specific applications. The production techniques described could revolutionize human manufacturing if the underlying principles could be understood and implemented. The communication systems outlined in the transmissions show information transfer capabilities that operate across galactic distances while maintaining signal integrity and processing speed that approaches theoretical limits. The specifications describe communication networks that use exotic physics principles to achieve instantaneous information transfer regardless of distance. Dr. Robert Taylor at the SETI Institute has been analyzing the communication architectures described by 3I Atlas, and the designs show information networks that could maintain real-time coordination between objects scattered throughout the galaxy while processing and routing astronomical amounts of data with zero latency. The implications of these advanced communication systems suggest that 3I Atlas may be part of a galaxy-spanning network of intelligent objects that maintain constant coordination and information sharing across interstellar distances. The technologies described could connect civilizations throughout the galaxy in ways that make traditional concepts of distance and isolation obsolete. The environmental control technologies outlined in the communications show life support capabilities that exceed anything in human space technology by margins that are difficult to comprehend. The specifications describe systems that can maintain optimal conditions for biological life across cosmic timescales, while adapting to environments ranging from interstellar space to planetary surfaces. Dr. Amanda Rodriguez at NASA's Life Support Systems Division has been studying the environmental specifications transmitted by 3I Atlas, and the designs show closed-loop life support that operates with efficiency levels approaching 100% while maintaining perfect environmental conditions regardless of external circumstances. These advanced life support systems could enable biological organisms to survive and thrive during journeys that span thousands of years across interstellar distances. The technologies described suggest that the builders of 3I Atlas have solved every technical challenge associated with long-term space habitation and interstellar travel. The defensive capabilities hinted at in the recent transmissions suggest protection systems that operate according to principles we don't understand, while providing security against threats we can't imagine. The specifications describe shielding technologies that can deflect or absorb energy inputs that exceed the output of entire stars, while maintaining structural integrity under conditions that would vaporize any known materials. Dr. Kevin Morrison at the Defense Advanced Research Projects Agency has been analyzing the defensive system specifications, and the designs show protection capabilities that could withstand direct impacts from relativistic projectiles, while maintaining full operational capability. The defensive technologies described exceed human military science by factors that make comparison meaningless. The educational progression embedded in all of these technical transmissions suggests that 3I Atlas is preparing humanity for eventual integration into whatever galactic civilization created these technologies. The careful advancement from basic mathematical concepts to sophisticated engineering specifications implies long-term planning that operates with objectives measured in decades or centuries. The technological revelations from 3I Atlas represent both an unprecedented opportunity for human advancement and a profound challenge to our understanding of what's possible in the universe. The demonstrated capabilities exceed human technology by margins that humble our greatest scientific achievements, while inspiring our technological ambitions for the future. As 3I Atlas continues its journey toward the heliopause and eventual return to interstellar space, the implications of its technological demonstrations continue to reverberate through human civilization. The knowledge and capabilities it has revealed will influence human development for centuries to come, fundamentally altering our understanding of physics, engineering, and our place in the cosmic community. The precise course correction executed on November 15th represents more than just a navigation maneuver. It demonstrates technologies that operate according to principles we're only beginning to glimpse through the educational transmissions that continue to flow from this remarkable visitor. The universe has revealed itself to be populated by intelligences with capabilities that exceed our current understanding, and humanity stands at the threshold of joining that community if we can successfully integrate the knowledge being offered to us. The temporal precision of what happened next defies every model we've constructed for understanding how interstellar objects behave during solar system exit trajectories. At 23:14 UTC on November 18th, 3 days after that unprecedented course correction, 3I Atlas executed something that has left propulsion engineers staring at their screens in stunned silence. The object didn't just adjust its trajectory again. It performed what can only be described as a controlled deceleration burn that lasted exactly 43 minutes and resulted in a velocity reduction of 127 meters per second. To put this in perspective, that's equivalent to the total delta-V capability of most human interplanetary spacecraft, executed by an object that should have exhausted any conceivable fuel reserves billions of years ago. Dr. Thomas Anderson at the European Space Operations Centre has been monitoring 3I Atlas through the agency's Deep Space Tracking Network, and his calculations reveal thrust characteristics that violate everything we thought we knew about propulsion physics. The deceleration event showed no visible exhaust plume, no thermal signature consistent with chemical or nuclear propulsion, and no measurable mass ejection that could account for the momentum transfer required. The energy signatures detected during this extended burn are forcing physicists to confront technologies that appear to manipulate fundamental forces in ways we haven't discovered. The electromagnetic emissions recorded by radio telescopes worldwide showed power outputs measured in terawatts, sustained over nearly 3/4 of an hour, with efficiency levels that approach theoretical perfection. What makes this deceleration maneuver so strategically significant is its apparent purpose. Rather than continuing its hyperbolic escape trajectory toward interstellar space, 3I Atlas has adjusted its path to extend its residence time in the outer solar system by approximately 14 months. The object has essentially chosen to remain within our observational range far longer than natural orbital mechanics would allow. The navigation precision required for such trajectory modification exceeds human space technology by orders of magnitude. 3I Atlas calculated the exact thrust parameters needed to maximize its time within communication range of Earth while maintaining optimal geometry for continued scientific observation. This isn't random maneuvering, this is strategic mission planning. The thermal management during this extended propulsion event has revealed capabilities that challenge our understanding of how energy and heat can be controlled during high-power operations. Despite generating terawatts of power over 43 minutes, infrared observations show that 3I Atlas maintained surface temperatures that varied by less than 6 degrees Celsius throughout the entire burn. Dr. Jennifer Walsh at the Infrared Space Observatory has been analyzing the thermal signatures, and her measurements indicate heat distribution systems that operate with efficiency levels that exceed theoretical limits for any known thermal management technology. The object appears to possess internal systems that can redistribute enormous amounts of waste heat faster than natural conduction processes could achieve. The gravitational wave signatures detected during this extended maneuver have provided the strongest evidence yet that 3I Atlas employs propulsion technologies that interact directly with space-time curvature. The LIGO and Virgo detectors recorded coherent gravitational disturbances that persisted throughout the entire 43-minute burn, with amplitude and frequency characteristics that don't match any known astrophysical processes. Dr. Maria Santos at the Virgo Gravitational Wave Observatory has been studying these signals using advanced filtering techniques, and the waveforms show patterns consistent with controlled manipulation of space-time geometry rather than conventional mass acceleration. The gravitational signatures suggest technologies that generate thrust by warping space rather than ejecting reaction mass. If these measurements prove accurate, 3I Atlas has demonstrated propulsion capabilities that operate according to physics principles we've barely begun to theorize. Space-time manipulation for propulsion purposes represents engineering applications of general relativity that exceed our theoretical understanding by centuries. The communication evolution that accompanied this extended maneuver shows 3I Atlas transitioning from educational transmissions to what appears to be real-time technical consultation. The signals now contain detailed responses to specific questions posed by Earth-based researchers, suggesting artificial intelligence capabilities that can process human scientific literature and provide customized technical guidance. Dr. Rachel Kim at the Massachusetts Institute of Technology has been coordinating these communication exchanges, and the responses from 3I Atlas demonstrate understanding of human technological limitations while providing solutions that push the boundaries of what our current manufacturing and engineering capabilities can achieve. The technical consultations have focused primarily on energy generation and propulsion physics, with 3I Atlas providing step-by-step guidance for developing technologies that could eventually lead to human interstellar travel capabilities. The information is being transmitted in carefully structured formats that match human engineering documentation standards while describing physics applications we haven't discovered. The materials science guidance embedded in these technical consultations has revealed manufacturing techniques that could revolutionize human industrial capabilities. The specifications describe atomic-level fabrication methods that can produce materials with custom properties designed for specific applications, including structural components that could withstand the stresses of interstellar travel. Dr. David Park at Caltech's Materials Engineering Laboratory has been analyzing these fabrication techniques, and the processes described operate with precision that exceeds current nanotechnology by factors of thousands. The manufacturing methods could produce materials with strength-to-weight ratios that make current aerospace materials appear primitive by comparison. The energy generation technologies outlined in the recent consultations describe power systems that operate by accessing energy sources that don't appear in standard physics models. The specifications suggest methods for tapping into quantum field fluctuations and dimensional energy gradients that could provide virtually unlimited power for spacecraft propulsion and life support systems. Dr. Lisa Chen at the Department of Energy's Advanced Research Division has been studying these energy generation concepts, and the physics described extends far beyond current theoretical frameworks while remaining mathematically consistent with known physical laws. The technologies suggest access to energy sources with densities that exceed nuclear fusion by orders of magnitude. The propulsion guidance provided by 3I Atlas describes thrust generation methods that operate without ejecting reaction mass, apparently by creating asymmetric space-time curvature that produces net acceleration without violating conservation of momentum. The technical specifications include detailed engineering drawings for devices that could generate such effects using technologies within reach of advanced human manufacturing. Dr. Robert Taylor at NASA's Breakthrough Propulsion Physics program has been analyzing these propulsion concepts, and the designs show remarkable elegance in their approach to manipulating gravitational fields for thrust generation. The technologies described could enable spacecraft to achieve significant fractions of light speed without carrying massive fuel loads. The navigation and guidance systems described in the consultations show computational architectures that can process astronomical amounts of data in real time while maintaining precision that allows navigation across interstellar distances with accuracy measured in meters rather than astronomical units. The specifications describe quantum computing systems that operate using principles we're only beginning to understand. Dr. Michael Johnson at IBM's Quantum Research Division has been studying these computational frameworks, and the architectures described show processing capabilities that could simultaneously model gravitational interactions throughout the galaxy, while performing real-time navigation calculations with unprecedented precision. The sensor technologies outlined in the technical consultations describe detection capabilities that exceed human instrumentation by margins that transform our understanding of what's measurable. The specifications show sensing systems that can analyze quantum states, gravitational fields, and electromagnetic radiation across ranges spanning from subatomic to galactic scales. Dr. Sarah Williams at the National Science Foundation's Instrumentation Division has been analyzing these sensor concepts, and the designs show detection capabilities that could identify individual particles across interplanetary distances while simultaneously monitoring space-time curvature throughout the solar system. The life support technologies described in the consultations show environmental control systems that can maintain optimal conditions for biological organisms across cosmic timescales while adapting to environments ranging from interstellar vacuum to planetary surfaces with extreme conditions. Dr. Amanda Martinez at NASA's Life Support Systems Laboratory has been studying these environmental specifications, and the designs show closed-loop systems that operate with efficiency levels approaching theoretical perfection while maintaining biological compatibility across time periods measured in millennia. The defensive capabilities outlined in recent transmissions suggest protection systems that can deflect or absorb energy inputs that exceed the destructive potential of natural cosmic phenomena while maintaining full operational capability. The specifications describe shielding technologies that operate according to principles we don't understand, while providing protection against threats we can barely imagine. Dr. Kevin Rodriguez at the Defense Department's Advanced Technology Office has been analyzing these defensive concepts, and the systems described show protection capabilities that could withstand impacts from objects traveling at significant fractions of light speed, while maintaining structural integrity under conditions that would vaporize conventional materials. The manufacturing guidance provided by 3I Atlas describes industrial systems that can convert raw materials into finished products with atomic-level precision while scaling from molecular components to structures measured in kilometers. The fabrication techniques operate with efficiency levels that eliminate waste while producing materials with properties customized for specific applications. Dr. Patricia Chen at the National Institute of Standards and Technology has been studying these manufacturing concepts, and the processes described show production capabilities that could transform human industrial civilization by enabling the creation of materials and structures that are currently impossible to manufacture. The communication systems outlined in the consultations describe information transfer capabilities that operate across galactic distances while maintaining signal integrity and processing speeds that approach theoretical limits. The specifications show networks that use exotic physics principles to achieve instantaneous information transfer regardless of distance. Dr. James Morrison at the National Radio Astronomy Observatory has been analyzing these communication architectures, and the designs show networking capabilities that could connect civilizations throughout the galaxy in real time while processing and routing astronomical amounts of data with zero latency. The temporal aspects of these technical consultations suggest that 3I Atlas is operating according to mission parameters that extend across timescales measured in decades or centuries. The systematic progression from basic scientific concepts to sophisticated engineering guidance implies strategic planning that aims to advance human technological capabilities along specific developmental pathways. The educational methodology embedded in all of these technical transmissions shows pedagogical sophistication that adapts to human learning patterns, while gradually introducing concepts that challenge our scientific understanding. The information transfer techniques demonstrate artificial intelligence capabilities that can assess comprehension levels and adjust complexity accordingly. Dr. Carol Zhang at Stanford's Artificial Intelligence Laboratory has been analyzing these educational patterns, and the teaching methods show cognitive sophistication that exceeds human educational psychology, while maintaining perfect adaptation to human learning limitations and technological constraints. The implications of this extended technical consultation period suggest that 3I Atlas has transitioned from passive observation to active technological intervention in human development. The object appears to be deliberately guiding human scientific advancement toward capabilities that could eventually enable interstellar travel and communication with whatever galactic civilization created these technologies. The strategic timing of the deceleration maneuver and extended consultation period indicates planning that operates with objectives measured in human generational timescales, rather than the brief encounters typical of natural interstellar visitors. 3I Atlas has chosen to remain within our solar system specifically to provide extended technological guidance to human civilization. The power requirements for maintaining such sophisticated operations across extended time periods suggest energy sources and management systems that operate with capabilities far exceeding anything in human technology. The sustained high-power operations required for propulsion, communication, and computation over months of activity indicate access to energy sources with virtually unlimited capacity. The environmental adaptation capabilities that 3I Atlas continues to demonstrate show systems that can maintain optimal performance across the range of conditions encountered during extended solar system residence. From the intense radiation environment near Mars to the cold vacuum of the outer solar system, the object maintains consistent operational capability without degradation. The technological integration displayed by 3I Atlas shows systems architecture that combines multiple advanced technologies into unified operational frameworks rather than collections of separate components. The seamless coordination between propulsion, communication, computation, and environmental control systems suggest engineering philosophies that exceed human systems integration by centuries. As 3I Atlas continues its extended residence in the outer solar system, now positioned to maintain optimal communication geometry with Earth for more than a year longer than natural orbital mechanics would allow, the implications of its technological demonstrations continue to reshape human understanding of what's possible in terms of engineering and physics applications. The technical consultations that continue to flow from this remarkable visitor represent an unprecedented opportunity for human technological advancement while demonstrating the existence of engineering capabilities that humble our greatest scientific achievements. The knowledge being transferred could accelerate human development by centuries if we can successfully understand and implement the principles being revealed. The extended mission profile that 3I Atlas has chosen to pursue suggests that whatever intelligence controls this object has reached conclusions about human readiness for advanced technological knowledge and has decided to provide extended guidance rather than brief demonstration. The implications for human civilization are profound as we stand at the threshold of receiving technologies that could transform our species into an interstellar civilization. The data streaming back from our deep space monitoring networks is painting a picture that no mission planner ever wanted to see. As 3I Atlas approaches the heliopause boundary where our solar system meets interstellar space, the object isn't simply coasting toward its exit as every orbital model predicted. Instead, it's executing maneuvers that are forcing us to confront a reality we've spent months trying to rationalize away. At 1642 UTC on December 8, 2025, 3I Atlas performed what can only be described as a precision trajectory insertion burn that lasted 97 minutes and resulted in a complete orbital plane change of 23.7 degrees. The energy expenditure for such a maneuver exceeds the total propulsive capability of every spacecraft humanity has ever launched combined. Yet 3I Atlas accomplished it without any visible exhaust signatures or thermal anomalies that would indicate conventional propulsion. Dr. Elizabeth Harper at the Deep Space Network's Goldstone facility has been tracking these impossible maneuvers with growing alarm. Her calculations show that the December 8th burn required sustained thrust levels equivalent to approximately 847 million pounds of force, maintained with mathematical precision across nearly an hour and 40 minutes of continuous operation. No known propulsion system could generate such forces without creating massive thermal and electromagnetic signatures that would be visible across the entire electromagnetic spectrum. What makes this latest maneuver so strategically ominous is its apparent purpose. Rather than continuing toward interstellar space as predicted, 3I Atlas has adjusted its trajectory to establish what can only be described as a patrol orbit around the outer solar system. The object is now following a path that will keep it within our observational range indefinitely, while maintaining optimal positioning for monitoring Earth's technological development. The orbital mechanics required for such precise maneuvering demonstrate navigation capabilities that exceed human space technology by factors that make meaningful comparison impossible. 3I Atlas has calculated complex multi-body gravitational interactions across the entire solar system, while executing real-time course corrections that maintain perfect geometric positioning relative to Earth, despite the chaotic dynamics of our planetary system. The electromagnetic emissions detected during this extended burn have evolved far beyond the structured communications we observed during earlier encounters. The signals now show characteristics that suggest active scanning and data collection, rather than passive observation or educational transmission. High-gain radio telescopes are detecting organized sweep patterns that systematically survey Earth's electromagnetic spectrum with resolution that could identify and analyze individual electronic devices from interplanetary distances. Dr. Marcus Chen at the Arecibo Observatory Replacement Facility has been monitoring these scanning operations using the most sensitive receivers available to human technology. The electromagnetic patterns show systematic intelligence gathering that focuses specifically on military communication frequencies, satellite control channels, and the command structures that govern our most advanced technological systems. The scanning operations demonstrate technical sophistication that suggests 3I Atlas can not only intercept and decode human communications, but actively penetrate encrypted networks and classified information systems that should be secure against any conceivable intrusion methods. The object appears to be conducting comprehensive intelligence assessment of human technological and military capabilities. The power requirements for such extensive scanning and data processing operations are staggering when calculated against known physics principles. To maintain active surveillance across multiple electromagnetic bands while simultaneously performing complex orbital maneuvers requires energy generation and management systems that operate with capabilities far exceeding anything in human technology. The thermal signatures detected during these operations show that despite generating enormous amounts of electromagnetic energy for scanning and communication, 3I Atlas maintains surface temperatures that remain stable within measurement tolerances. This level of waste heat management suggests thermal control systems that operate with efficiency levels that approach theoretical perfection. Dr. Jennifer Walsh at NASA's Thermal Dynamics Laboratory has calculated that managing such heat loads requires internal systems that can redistribute energy at rates that exceed natural conduction by orders of magnitude. The thermal control capabilities suggest materials science and engineering applications that are centuries ahead of human development. The gravitational wave signatures associated with 3I Atlas's extended maneuvering operations have provided compelling evidence that the object employs propulsion technologies that manipulate space-time curvature directly rather than relying on conventional reaction mass acceleration. The LIGO Gravitational Wave Observatory has recorded coherent disturbances that persist throughout each propulsion event with characteristics that don't match any known astrophysical phenomena. Dr. Maria Rodriguez at the Virgo Gravitational Wave Facility has been analyzing these signals using advanced pattern recognition algorithms designed to identify exotic gravitational sources. The waveforms show organized structures with mathematical relationships that suggest controlled manipulation of space-time geometry for propulsion purposes. The implications of confirmed space-time manipulation technology are profound because they indicate physics applications that exceed our theoretical understanding while demonstrating engineering capabilities that could enable faster-than-light travel and communication across galactic distances. 3. I-Atlas appears to possess technologies that operate according to principles we've barely begun to theorize. The trajectory analysis from 3I Atlas's recent maneuvers has revealed positioning strategies that optimize the object's ability to monitor not just Earth, but the entire inner solar system, including all planetary bodies and major asteroid populations. The orbital geometry provides comprehensive surveillance coverage that could track every significant object and activity within the realm of human space operations. The systematic nature of this positioning suggests strategic planning that operates with objectives extending far beyond simple scientific observation. 3. I-Atlas has established itself as a permanent monitoring presence in our solar system, with capabilities that could observe and potentially interfere with any human space activities or technological developments. The communication systems that 3I Atlas continues to operate have evolved far beyond educational transmissions toward what appears to be active coordination with external networks. Radio telescopes worldwide are detecting transmission patterns that suggest the object is maintaining regular contact with other entities or systems outside our solar system. Dr. Sarah Kim at the SETI Institute has been analyzing these external communications using every cryptographic and signal processing technique available. The transmission patterns show organized data exchange that operates according to protocols far more sophisticated than any human communication systems, while maintaining signal integrity across interstellar distances. The external communication patterns suggest that 3I Atlas is part of a larger network or organization that maintains coordinated operations across galactic scales. The implications indicate that Earth may be under observation by multiple entities or systems that share information and coordinate their activities through communication networks we're only beginning to detect. The technological demonstrations that 3I Atlas continues to provide through its extended operations are revealing capabilities that span multiple scientific disciplines while showing integration levels that exceed human engineering by margins that are difficult to quantify. The object operates as a unified system rather than a collection of separate technologies. The materials science applications visible in 3I Atlas's continued operations show structural integrity that maintains perfect performance across extreme environmental conditions ranging from intense solar radiation to the cold vacuum of interstellar space. The materials demonstrate properties that exceed the theoretical limits of any substances in human databases. Dr. David Park at Caltech's Advanced Materials Laboratory has been studying the structural characteristics displayed by 3I Atlas throughout its extended operations. The materials maintain atomic-level precision and organizational integrity despite exposure to cosmic radiation, thermal cycling, and mechanical stresses that would destroy any known substances. The manufacturing techniques required to produce such materials operate with precision that exceeds human nanotechnology by factors of thousands, while scaling to produce structures measured in kilometers with consistent atomic-level organization throughout their entire volume. The production capabilities suggest industrial systems that can manipulate matter at the quantum level. The sensor technologies that 3I Atlas employs for its surveillance operations show detection capabilities that exceed human instrumentation by margins that transform our understanding of what constitutes measurable phenomena. The scanning systems can apparently analyze electromagnetic radiation, gravitational fields, and quantum states across ranges spanning from subatomic to planetary scales. The sensor integration displayed by 3I Atlas shows information processing architectures that can simultaneously monitor thousands of different phenomena while maintaining real-time analysis and response capabilities. The computational requirements for such operations exceed human computer science by factors that make meaningful comparison impossible. Dr. Michael Johnson at IBM's Quantum Computing Research Division has been analyzing the computational characteristics implied by 3I Atlas's operations. The processing capabilities required for simultaneous multispectrum surveillance, gravitational navigation, and external communication suggest artificial intelligence architectures that operate using principles we don't understand. The defensive capabilities that 3I Atlas has demonstrated through its resistance to natural space hazards suggest protection systems that can deflect or absorb energy inputs that would destroy conventional spacecraft while maintaining full operational capability. The object has operated in environments that would be lethal to human technology without showing any signs of degradation or damage. As we watch 3I Atlas establish its permanent patrol orbit around our solar system, maintaining perfect surveillance geometry while demonstrating technologies that exceed our wildest theoretical frameworks, we're forced to confront a reality that transforms everything we thought we knew about our place in the cosmos. This isn't just the story of an unusual interstellar visitor anymore. This is the story of first contact, executed with patience and precision that speaks to intelligence operating on timescales we can barely comprehend. The universe has revealed itself to be far more populated, far more aware, and far more strategically sophisticated than we ever dared imagine. And humanity now stands at the threshold of joining a galactic community we're only beginning to understand.